afternoon session. So I request all to be ready with some pencil and scale for making it happen, huh? Because we need that for exercise. Okay, right? So some basic history about SPC we can just discuss, because it was started around 1928. There is introduction of SPC by uh, Walter Sheward. He has started this graphical tool first. Mr. Walter A. Sheward, okay, in Bell Laboratories. So it has been started in America, then made popular to other area of the world like Japan. All the industries started using this. Deming has played a very pivotal role in making it famous and making it used by other industries. So that way, SPC has started. So what is SPC exactly? Some definitions we can say. SPC is an analytical decision making tool which allows to see the process is working correctly, or when it is working correctly and uh, when it's not working properly. We can say within specification or within control, how we are controlling, how the process is behaving. All these things we can find out by using process behavior, discover the issues in internal system. So internal system is all the systems like forum, we can see uh, forum, all the what are the things we use as an input for making any product or services, right? Use of statistical, you can see the use of statistical techniques and control chart to analyze the process. It is required. Then based on that, we need to maintain statistical control and improve. We need to control, then improve. So all these we can get after implementing SPC. So just to know whether our process is in control or not. Then if it is in control, just improve again. So improve to the next level. That way, it is like a continuous improvement sort of thing, like PDCA cycle. We do that. So based on that, we can improve the product quality. So again, it has been I discussed by Mr. It was led by Mr. Walter A. Sheward and developed the concept regard to variation. So it is done after maybe the World War II. It has been made famous. You can see there are a lot of evolution in Japanese industry. So it started and it started in America, then Bell Laboratories, then it has find a way in other part of Japan and other industries also. Mr. Deming has played a very famous role in making it, you can say, famous, and he made it famous. And you can say SPC is used because there are some lectures Edward Deming has given to some of the industries in Japan also to develop their quality. So that way, the SPC has been started. You can say. So, what are the roles of SPC? So, how the production costs will come down if we use SPC? Could you please say how we can relate production costs? Yeah, anyone?
We will be
Yeah.
able to reduce the defects in the system. So the if the number of defects are going to come down,
Okay.
automatically we will be able to
Right.
increase our
Right.
production,
Right.
and
Right.
we will be able to reduce our waste basically.
Okay. 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 Right. Right. Yeah, it will improve our productivity also.
Definitely.
So if you do SPC, is it result in improving the productivity also?
Yes, it will increase because we will be reducing our rework.
Okay, okay. Right,
Like
right. Definitely, if
simultaneously
you,
that
yeah.
bad part converted into good parts.
Okay, okay, okay.
Correct.
Yeah, yeah, yeah. So it is hitting P also, huh? PQDSM, you know that. So in that, it will hit even the productivity also, huh? Right? So consistency of to attain a consistency of products and services that will meet production specifications and customer expectations, right? So create opportunities for all members organization to contribute for quality improvement. So how can we do that? How all the members will get an opportunity, especially in SPC? Very important, very important. You need to relate with your industry, how the people get an opportunity to improve. All the operators, we can say, all the operators, all the people working in the shop floor, how they will get an opportunity to improve.
To get the
Actually,
data, to collect the data.
yeah, right, right. Yeah. Collect the data, maybe some of the action, right? After that,
Actually, control chart is provide the variation status at the machines.
okay, okay. Who will be doing that? Who will be doing that? That is very important.
That is doing by the operator and
Very good,
during
very
that
good.
line
See, yeah, yeah, yeah,
variable.
yeah. Yeah, yeah. See, SPC should be done by the operator. See, the people who is operating their machine, they should do the SPC. At least the charting of the parameters they have to do, right?
Right.
Some of the functions, some of the areas like maybe new product development, some approval, some process or design team will be doing during that time. Regular production time, it has to be done by the operator who is working in the shop floor. Then only you will get the exact benefit of SPC. Agree with me?
Yes, sir.
Yeah.
Actually, operator provide actual data. He measured
Yeah,
and
yeah, that is very, very important. That is one of the other key point because they know why the variation is happening. So if some of the parameters is going out of the specification, out of the control chart, out of the control limits, so they know the exact root cause. So other people may not have that much, we can say, technical capability and real facts. They know where the variations are coming, right? So, by the way, management and employees should make a economically sound decision. We cannot put a lot of money for some actions. It should be a sound decision that will giving a good result, right? These are the primary goals we can say. So, have you heard about the AAG? So, this is AAG. Just yeah,
automotive industries action group. I think
yeah, yeah, yeah.
this
Right.
is
It
the
is. Yeah.
organizations which is provide the guidance for the automotive industries.
Okay, okay, okay. See, this has been provided for the automotive industry, but these tools has been used by other industries also, right?
Yes.
Only the requirements may not, maybe some small changes will be there, but the principles is being used by other industries. But it has been made famous and popular by AAG, you can say, right? AAG stands for Automotive Industry Action Group. Uh, right? This is just an organization and it has been found by 3M, you can say, three major automotive industries, right? That is one
Right.
is Ford, yeah, that is one is Ford, then GM, then Chrysler, right? So they made this because they want all their supplier to be in a same standard, to follow the same standard. If you supply any of the part from here to even to Germany also, to even in India also, the quality of product should remain same, right?
Right,
So
sir.
for that, yeah, they have developed this standard. So Quality core tools also you may aware about the quality core tools, right? How many quality core tools are there? There is a
5 to
mistake. Yeah, there is a mistake in this. Could you please
5
find
core
it?
tools.
Yeah,
Actually,
yeah,
the
yeah,
control is not considered in the list.
yeah. Yeah, any other answer? This is this is what we can say. It's okay or there is a mistake.
No, it is okay. Currently,
Because
as per the latest revision in the APQP, the control plan has been excluded from the APQP activity. So now the code tools is 6.
Yeah. Who is speaking? Who is speaking? What's your name?
Amar
Amar.
Shukla from Statistical Process Control, Quality Department.
Yeah. Very good, very good. Right answer. See, the quality core tools has been the control plan. You can see it has been added recently.
Yeah.
So before there were five quality core tools we can say. Now
Yes.
the recently control plan also got added, right?
Yes.
Okay. See, and for these to learn, see you there are deep knowledge. There are a lot of materials, lot of we can say you need to spend almost 2 3 days training for each session to understand fully deeply about each session, right? So today we will be touching on SPC only. There are PPAP, there are FMEA, there are MSA, sorry, and APQP also, right?
Right.
Okay. And which edition we are following SPC? What is the current edition?
I think second edition.
Yeah, the SPC, the second edition is used by all the industries. Please, you can note down. You can note down this. If something is shared, something is specifically we are talking, you can note down in your notes. Huh? Yeah, right. Am I audible now?
Yes, sir.
Yes, yes. Some people are getting joined still. Yeah. Okay.
इन्वेस्टमेंट कार्ड अप्लाई करेंगे लाइफ टाइम के लिए और रुपए क्रेडिट कार्ड है लिमिट भी कर रही है जा
1 minute. My screen is not moving.
चाहिए कोई ज्वाइनिंग फीस नहीं 90 दिन तक है
तो जितना बढ़ेगा सारा उतना इतने सारा सेव कर देंगे हाँ तो करवा मेरे
Is my screen is visible?
नहीं मेल पे
Yeah, it's visible.
Yeah. Okay. Okay.
Am I audible? I am visible.
वही करो कुछ काम की बात तो कर ही नहीं रहा है पहले तो इंट्रोडक्शन ले रहा है ना आधा घंटा इंट्रोडक्शन लगा दिया इसने
क्या सबसे
हाँ
सबसे हाँ
Gaurav, are you there? Who is this Mr. Gaurav? He's from which industry? Mr. Gaurav, are you there?
Yes, sir. We are Gaurav is from Statistical Process Control. We are joined together.
Okay. But Gaurav Sharma, someone is trying to join and is getting stuck.
Yes, actually, due to the internet, over internet, I'm leaving.
और नोएडा
Yeah. Okay. You can join in the same laptop, huh? Don't send the request again, huh?
Sure, sir.
वही ज्वाइन करना चाह रहा हूँ
Hello.
Yeah.
5 बजे तक
Hi sir, I am Sejal Patel from Jyoti World. Actually, I'm trying to unmute myself, but not able to do unmute or any video or anything. That's why I connected from this different system. So
Okay, okay, no issues, no issues.
yeah,
Now you're okay,
yes,
no? Okay, okay,
yes.
welcome. Huh? Okay.
पीछे पूरा चार्ट बना रखे हैं स्टैटिस्टिकल डाटा लगा हुआ है इसी को खा रहा है सब रोक कर रहा है वो उसके लिए है दिखा दो एक बार फिर बात करो अभी चाहे
मिश्रा जी ने कल उनको वो बताया कि हमारे ऑटोमेशन में क्या है।
Sorry, my screen was not showing. Okay.
सब बता
So you are clear with the AAG which standard SPC we are using, right? So which edition we are using?
second edition
Second edition. Okay, right. Huh?
मिल जाएगा वो मेरे को।
There are 6 quality tools. Huh? Remember that. Huh? The
Sir,
recent update.
Hello.
Yeah.
Sir, second edition for 2008 na sir.
Exactly, it is almost 2002 only. Maybe after that, only some corrections may be there. That's all. Huh? But the edition will be same. Huh?
क्या होता है?
Major will make change the edition. Right? Otherwise, small note changes.
इसका SPC का
Okay.
यार पहले ही समझ लें हम।
So before getting into SPC, you see, you know, data is very important for SPC, right? Agree with me?
कितने दिन का है
एक ही दिन का है।
Yes. See, data is a factual information used as a basic for reasoning, discussion, and calculation, and for taking the decision also. So data is very important. Huh? So data allows us to make the educated decision or meaningful decision, and based on that we should take the actions. So before taking any action, what we do, we collect the data. We will be doing some calculations. So we will do the interpretation. We will make some decisions based on meaningful decision from the analysis of actual data. That is very important. So in this case, in SPC, we should take the actual data, right? This is very important, and it has to be from the Gemba, right? Huh? Agree with me? Yes. See, what happens? See, how many people are already using SPC? How many are using?
नहीं है।
काम सारे करते हैं
Or how many of the industries are already using?
कर रहे हैं।
Directly or indirectly?
बस
Yeah.
साबित
Amar Shankar, yeah.
नहीं ये दिखा
Yeah, we are using sir.
डाटा बना के दिखा दिया
So how many people are using actual data?
No, we actually we are working with actual data.
फेक डाटा
Okay, then very good. See, some people for the customer approval, they may be doing the manipulations in their calculations, right? Agree with me?
उसने भेज दिया
Some changes.
उसका वो लिया
Feedback, that's also true.
वो
Yeah.
पता है कि नहीं है।
So that is there in many of the industries. But to learn about SPC and to get the actual benefit for the industry, or to get the benefit for your product, you should use the actual data only, right? Then only you will get the actual benefit. Then other decisions based on some you see, factual information is very important, right? So why data is, if we don't collect data about the process, then what? Without data, we don't understand the process. Why we are taking the data? To understand the process, right? Yeah. We are taking the product details and we are understanding the process, right? So without understanding the products, we cannot control the outcomes. To control the outcome, we should understand our process also. How the process is happening. See, if someone doesn't know what are the process, how the part is made. So what are the process behind that? What are the technical details behind that? So he cannot take any decision. He cannot take an action, right? Agree with me? See, along with the SPC or system knowledge, you must have some sort of technical knowledge about the process also. So our data is very important. To where it is it important to control the outcome? When you can't control the outcome of a dependent, you are dependent on a chance. If you are not controlling your output, you are waiting for the chance. So the output may come rejection, it may come with some sort of variation, so rejections will come. So it all depends, you are depending on the chances, chances or luck. You are not taking proper actions, right? So your process always will be maybe that there are chances of producing either rejection, rework. There will be a pile up of all these no, non-value added activities will be coming, rework, inventory, all these waste will create up, right? So data is very important, right? So if you don't collect data about the process without a similar I think similar slide, right? Okay, so in there are two types of data. What is that? There are
At-
yeah yeah
Attribute and variable.
yeah. Attribute and variable, right?
Very good. Correct.
Right. Okay, what about other team, agree with me, or there are three types of data or two types of data? Mr. Saumidev, yeah, what's your opinion?
Yes, sir, there is two types of data, qualitative, quantitative, I think. In
Okay, you are,
qualitative,
yeah, two you are saying, right?
yes, yes.
Okay, yeah. Mr. Naveen, what's your opinion, Mr. Naveen from Filtrate?
Yeah, there is it is only of two types. One is attributes and one is the variables.
Okay, right. Okay, so generally it is there are two types of data. So based on that only, all these we can say there are measurement gauges also for measuring. You can say so. So measuring attribute data, we can call it as attribute gauges. For continuous data, there are different set of gauges, right? Gauges or measurement systems what we use. So we'll start with continuous data. Continuous data are measurable. So to measure, you can say continuous data is in the form of measured, or it will be like in a scale. You can say the examples like temperature, pressure. So any other example for continuous data? Yeah, could you please say the examples for continuous data?
Its length, width, outer dial, inner dial, that can be measured directly.
Okay, right. Okay, continuous data. Okay. The gauges you use for those, we can say that variable measuring gauges, right? Okay,
Okay, sir.
right. Yeah. In this, I think there is no doubt with the continuous data. We'll go to attribute data or discrete data. So attribute data is something, data is discrete and counted. In counted numbers, we can say, just take an example, okay, not okay, right? We do all these inspections, right? So in this, we may get some products good, bad, some items are present or absent. The answers will be almost like qualitative figures will come, right? Agree with me?
Yeah.
Yes, sir.
Okay, our is number of defects, number of blowholes, number of scratches, all these called as attribute data. So clear with this, right? So the entire SPC process will be like this. we'll be collecting the data first, then we'll use some statistical tools here. We'll be using control chart and all. We will analyze the data. We'll calculate the capabilities of each process. Then information that can be easily understand, and then we can take the action. This is a we can say the flow of the process, right? Okay, this basic principle is clear, right? Yeah. If you have any doubt, you can just stop me and ask and get it clear. Huh? Because while going to next session, when we move ahead, there are because it is more about some analytics you need to understand. Then only, or else if you doesn't understand basics, you cannot understand the deeper details of SPC. That is very important, right? So these are similar things already you know. So just I'm touching on basic things again. What are the different types of data? What are the basic calculations we do in SPC? That also will be covered in the next coming slides. Okay, principle is just getting for SPC, what we do is just collect the existing data, what is happening now, just collect the data, and we are product. We can we are taking a decision on the process. We are saying how the process is behaving. You are learning. We are studying the process, and even we can predict the process, how the process is going to behave in the future. Clear? Keep in mind, just like we what we can say, just learning about the current stage of the process, and we can predict how the process is going to maybe going to behave in the future. In that, there may be some sort of error. Still, maximum time the process will be behaving almost similar if the conditions are maintained, right? So this is the overall SPC system. So you can see the entire SPC system here. You can see for any product there will be some sort of input, right? Agree with me? So what are the inputs for like this one, for any for your process? Am I audible, right? What are the inputs, you can say? You agree with this the things lifted here, or you want to say, right?
Yes, sir. We agree, sir.
Right. So for like we use no 4M or 5M, all these, huh?
Yes.
Man, machine, material, and mother environment is some conditions, huh? Some people can say considers man, equipment is machine, then material, method, and environment, right? These things are the inputs for any process. You can see the process over here. This is the process. So in this process is maybe defined by the customer how to produce, which are the operations to be done. Then after that, some outputs will come. Some outputs may come. That output may be in the case of service industry, it will be service. Other industry, it will be output. Then it will be getting delivered to the customer, right? So customer may be changing here his expectation, and maybe giving some sort of we can say other requirements, extra requirement, because then what we will do, that is called as voice of customer. Agree with me? Customer is always the king. So he wants to change. He wants to maybe uh, for some he may be asking something extra other than the drawing also. Agree with me? It's not always aligned with the drawing or something, right?
Yes, sir.
Yes. So we'll be getting some sort of inputs related to any concerns or any improvements related to the product also. So that also we will take as an input and we will capture here. Again, there will be changes. So this is called as voice of customer, right? This is called as voice of customer, right?
Excuse me. Actually, I have one question.
Okay.
Say that voice of customer. In some cases, if your process is stable
Mm-hmm.
and your machine is capable for example, I am producing that part is plus minus per diameter zero point 0.1 tolerance.
Okay.
But that voice of customer is expecting that it should be 30 micron or 40 micron, and he's trying to change that tolerance.
Okay.
So in that case, how to address it? So I
See,
cannot change that these 4M inputs.
right. That depends on your process knowledge and technical
You got my
things.
point, na?
Right. We
That
understand.
is
You
also
will
voice
get
of
a
customer.
yeah. You will get an idea. Maybe after the training session, you will get a proper idea about this. You can do based on your process improvements how the process is capable, right?
Okay.
Okay. Uh,
बोल ही दे दिया। अरे
wait a minute.
ऐसा उन्होंने बोल दिया तो ठीक है, तुम्हारे बस में नहीं है, मत करो।
जब तक आपका स्टेबल चल रहा है।
हाँ, जब तक स्टेबल चल रहा है। जब आपको लगता है कि नहीं करना पड़ेगा, मेरे को बचाना है इस कस्टमर को, तो करना ही है।
Team, can we have a 5 minutes break now? We can break for 5 minutes. Then we can join back. 11:05 we can join back. Okay?
Okay, sir.
Okay.
Yes, sir.
Okay, sir.
Yeah.
टी ब्रेक है, सारा 14 स्लाइड ही दिखाया है। जो हमारे
हमारे कस्टमर का क्या रोल है?
हाँ?
हमारे कस्टमर का क्या रोल है?
टोटल 105 स्लाइड है।
आपको कस्टमर का ये रोल है कि आपका फोन आया था कि एसी खराब हो रहा था मेरा।
वो नहीं है।
और
वो भी आपके कस्टमर है। आप हमारे पास हमारे कस्टमर।
अरे सुनो, अभी बताया ना ओवरहेड का पंप नहीं चल रहा है। अब आप उसने बोल दिया कि मेरा काम नहीं है।
फीडबैक और ले लो, फीडबैक और लो तुम।
जिससे तुमने कहा उसने मना कर दिया कि मेरा काम नहीं है।
हेलो सर, स्क्रीन शेयर हो रही है सर आपकी।
कहा कि ये काम कर दे, उसने मना कर दिया कि मेरा काम नहीं है।
अच्छा,
हाँ,
कौन?
किससे बोला है भाई?
सर ने अपनी टिकट करने लग गया, आपको बोला। टिकट करने लग गया।
टिकट करके तो इसीलिए 5 मिनट रुका था।
अच्छा, टाइम हो गया क्या? 10 मिनट।
Nikhil, your screen is still shared.
11 नहीं खुलेगा।
तत्काल
यार, अब हो गया नहीं। ये उसका है ना, स्लीपर वाला है।
तत्काल वाला कर रहा होगा तभी उसने देखा कि टाइम हो गया, जल्दी करो। कितने देर ब्रेक दिया इसने? 5 मिनट का।
जैसे टिकट होता है,
जैसे टिकट हो
इसके बाद नहीं सब मिलकर आ जाते
हो ना?
अरे कटियार जी, आपने तो अपने ऑफिस की मिठाई तो खिलाई नहीं। क्या तो इतना बढ़िया बड़ा मतलब लोग तो कल तारीफ कर रहे थे तो सर देखो कितना बढ़िया ऑफिस बनाया और वो बनाया है। अच्छा, चलो यार, फिर तो जाके देखना पड़ेगा। इसलिए हम अपना ऑफिस तुरवा रहे हैं।
अगली बार ना यहाँ बोलो कि ये बंदी चीज लगनी है यहाँ पर, क्यों?
अगली बार क्या, इस बार लगनी है।
अच्छा,
सारी चीज तुरवा रहे हैं हम।
क्या लगवा रहे हो?
इंस्ट्रूमेंट का ऑफिस लेंगे भाई हम, क्यों? इंस्ट्रूमेंट का जो बगल वाला वर्कशॉप है ना, उसको क्या लेते हैं।
और यहाँ लगोगे हम, क्या लगोगे?
यहाँ मिल लगा देंगे।
मुझे हमने पंखों क्या हुआ है, पंखे रिपेयर होने गए, वो आए नहीं वापस।
कौन सा पंखा रिपेयर होगा? वॉल फैन रिपेयर नहीं होता है। तुमने यार सीलिंग फैन लगवाया नहीं उस ऑफिस में?
कहाँ पर? यहाँ? अरे अच्छा लग रहा था।
क्या बात, अच्छा, अच्छे से क्या मतलब, अच्छा तो वैसे और भी कुछ बहुत कुछ ही नहीं लगता।
अच्छा लग रहा था। हाँ, 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 अच्छा लग
यहाँ क्यों लगा सीलिंग फैन है? यहाँ अच्छा लग रहा है।
यहाँ चलो
क्या बात है?
स्ट्रक्चर वहाँ तो ऐसी है।
अच्छा, स्ट्रक्चर ऐसे क्यों?
वहाँ सब ऐसी
क्यों?
बढ़ रही है।
ऊपर ये फॉल्स सीलिंग नहीं है वहाँ? फॉल्स सीलिंग भी है?
फॉल सीलिंग जो है
तो फिर
वहाँ थोड़ा प्रिंटेबल होना चाहिए, है ना?
भाई साहब, मैं बता रहा हूँ वॉल फैन कोई वो नहीं है, आप सीलिंग फैन लगवाइए।
ठीक है
हाँ?
हो गया सर।
वो तो हमें सुबह पता लगा कि जलंधर गए, हमें बताया भी नहीं।
जलंधर चेन के लिए क्या बात है?
जो परासर गए, हमें तो बताया नहीं। अच्छा लगा ऐसे कम्युनिकेशन है, तुम लोग ऐसी ही है वैसी ही है।
अच्छा अभी भेजा देखो 10 मिनट में नहीं आ रहा बताना है।
सब ट्रांसपेरेंसी रखनी है, फिर बाद में ट्रांसपेरेंसी खत्म हो जाती है।
ट्रांसपेरेंसी इसलिए रखनी है कि जो तुम कर रहे हो हमें
पता लग जाए। स्टार्टिंग में यही है,
उसके बाद
ट्रांसपेरेंट रखिए, ट्रांसपेरेंट। और अब ट्रांसपेरेंसी खत्म हो गया,
पता नहीं लगना चाहिए, वो ट्रांसपेरेंसी खत्म हो गई।
वो ट्रांसपेरेंसी खत्म हो ही रही है। अब जैसे तो कुछ
सब
पता लग
गया
गया।
है। कोई बात नहीं, बहुत सारी ऐसी ट्रांसपेरेंसी आएगी कि तेरे ऊपर आएगा कि जो ट्रांसपेरेंसी तो है ही नहीं, कि क्या करें बताइए। कल पूछना सर, तो ठीक है कल आएंगे।
नहीं, मैं फोन आया था सुबह कि मीटिंग कर लेना।
अच्छा,
तो मैं सर आप कहाँ हो? यार मैं जलंधर आ गया था। मैं जलंधर क्या हो गया सर? कल तो कोई बात आपने बताई नहीं हमें। अरे नहीं यार, रात में अचानक से प्रोग्राम बन गया है।
अच्छा अचानक रात में अचानक से इतना प्रोग्राम चीन वाले ने कहा रात में 10 बजे की जल्दी आ जाएगी, बस 2:30 शुरू करने वाले हैं, फीते काटना है।
क्या कर रहा है? ओवरहेड
चैनल में 20% तो कम कर देगा पैसा, मैं कम करवा दूँगा। देखते देखते पहले वाला सही दिखा है, चेन नहीं खेलनी चाहिए, रिपेयर नहीं करानी चाहिए।
पूरी तरह चल ही नहीं रहा ना।
20% कम करा देना पैसे।
सर वो ऑपरेटर है क्या?
हाँ प्रदीप है ना,
प्रदीप ये डर्टी काटो पे रहता है ना प्रदीप।
बात करते ऑप्शन ही नहीं है। पहले वालों ने जो किया था वो सही किया था, कुछ सही नहीं है।
ये तो सबने जितने नए आ रहे हैं सबने वही कर लिए ना। ऊपर में जितने आए थे ऊपर वाले माले में, सब नीचे वाले जो सब काम खराब कर रहे हैं। ये करना चाहिए, नया करना चाहिए, ऐसा करना चाहिए, ऑडिट करना चाहिए।
अब ऊपर वाला देखो कॉन्ट्रैक्टर दे नहीं पा रहा, बोल रहा है कि आप बता दो।
हाँ
यार कोई बता दो। हमने तो बिल्कुल ऐसे हाथ छोड़ दिए,
बिल्कुल
साला वहाँ जिसको मर्जी उसको दे।
हम भी हम तो कॉन्ट्रैक्ट बना के भेज दे रहे हैं। तेरे को बुलाना,
10,000 का कॉन्ट्रैक्ट में तू नेगोशिएट कर ले, जिसको बुला कर देना दे।
उस दिन
अब क्या है, 20,000 का अभी एक काम दिया, 40,000 का काम है, दिया 70,000 रुपये में। और क्या नहीं, हमने एस्टिमेट बना के दिया।
एस्टिमेट चेंज मत करो,
एस्टिमेट चेंज करने के लिए बोलता है।
वही
हमारे साथ भी तो है ना,
सारे सब वही दिक्कत यही है कि
तो मैंने तो एक लाइन लिख दी उस पर, एस्टिमेट मॉडिफाइड अकॉर्डिंग टू द परचेज डिपार्टमेंट,
इस पर लिखा
PR पड़ी ऊपर। फिर वो होता है
नहीं तो एस्टिमेट हमसे मांगा ही क्यों जाए, चेंज ही करना है।
तो इस बार एस्टिमेट दिया ही नहीं मैंने, मिल वाले काम में एस्टिमेट दिया ही नहीं। हाँ तो अपने आप कर ले।
एस्टिमेट देना पड़ेगा ना, लाइन लिखी सही लिखी है नीचे टेक्स्ट में।
वो तो बोल ही रहा है कि ये लाइन क्यों लिख दी।
हां सही है, मैं बोला ये नीचे टेक्स्ट में लिख देता ना, टेक्स्ट में।
हां वो तो यार जा चुकी है, अब उसमें कुछ चेंजेस करा।
अच्छा वैसे मैंने हाथ से लिखा है।
हाथ से लिखा मैंने तो
सही है, जो भी भेजो लिख के भेजो। नहीं पिछली बार तुम मेरी लड़ाई में मैंने तो चेंज करना अपने करो।
हां
हम तुम काट के उसको कर दो, आसान कर दो अपना। हमसे क्यों करा रहा है?
और देखो हमारा एस्टिमेट ही है। मैंने दीपेंद्र को बोला अगर मैं पार्टी लाऊंगा तुम बोलोगे तुम करवा लो ऐसे ही, ये आपने कम दे रखा है, मैं तो करवा तो दूंगा, तू लेकिन उसके पीछे पड़ जाएगा।
नहीं हमें लाना ही नहीं है, तुम ही करो जो करना।
मैं बोला तो एक काम कर, मारवाली करते हैं हम दोनों, तो इतने में दे रहा है, इतने में दे इसको, मैं बोलता हूँ बता।
जहाँ अपना मतलब होगा ना, सर करा दो, सर मर गया जी, जी गया जी, जहाँ ये दिखेगा कि 2-3 ऑप्शन है वहाँ पर चौड़े हो जाएंगे। जरूरी इशू थे ना, 6 महीने हो गए, एक पंप का सर्विस इंजीनियर ने ढूंढवा है, हमने एक उससे ऑथराइज डीलर से कोटेशन लेके भेज दिया था। राकेश जी का फोन आया, जरूरी इसी से करना।
Bhupesh, what's the issue? Am I audible now?
ऑथराइज होना चाहिए। 6 महीने हो गए,
Bhupesh Yadav.
3 रिमाइंडर भेज चुका हूँ मैं। सर्विस इंजीनियर
Yes, sir, you are audible.
कंपनी से बुलाऊंगा, तो बुला भाई।
टिकट होगी उसकी।
चेहरा बताएगा, कुछ नहीं। सर कहाँ जा रहे हो?
So anyone from Murugappa has joined? Murugappa Morgan?
Hello?
Mr. Sundar Ramesh, are you there?
कहाँ से? हाँ, सब चलेगा टिकट बुकिंग करने। एक लाइट देखने गया, देखने तो सर लाइट में है ना, पूरा प्लान में स्पार्क हो गया, देख रहा है, देख ही जाएगा। पूरा प्लान में स्पार्क हो गया। गोडाउन वाले हैं, जो आदमी चाहिए नहीं, आप इतने काम है आपके भी, 50 काम है यहाँ लाइट लगाना है,
Can we start again? All are there?
Yeah.
Yes, sir.
Mr. Sundar Ramesh has joined. Mr. Sundar Ramesh, are you there?
तीन में से छोटा वाला जो भी है, कोई है क्या?
Okay. See, coming to the slide again. There are some of the other points also to be considered in voice of customer. What are that? Voice of customer.
I think the feedback of the customer.
Okay. Yeah. Feature you are saying. One more thing. One step ahead. You should go. Right? See, they will be giving. Yeah, they will be giving. First of all, they will giving the drawing or specification. They will be defining the specification, right? Who is defining the specification of parts? Who is defining the specification? Specification limits.
Customer defining.
Yeah, right. So it is called as voice of customer, which is defined by customer, right? So in this you can see there is a voice of process. So what are all the things? Sorry.
Process control.
Let me erase. So what are the things related to voice of process?
I think the voice of a customer must be a voice of process, because the customer, what is the customer requirement, depending on the process will be made in the future.
Okay.
And the expectation then meet the customer.
You're thinking, yeah, the thinking is correct. But in this case, voice of process is a different thing, huh? See, voice of process. If someone else want to speak, what is voice of process? You must understand voice of process.
The voice of process is process should be meet with the specification.
Right.
The output should be in good quality.
Okay. See,
parameters.
So the changes required by the process to meet the output specifications.
Right. See, here some specifications, they will be giving the specifications, all these. Then we will start making the part. So during the process, there will be some issues. There will be variations. Sorry.
Variations.
Right? see these variations, issues, all these concerns are coming from the process. So it is called as voice of process. It is variation of the process, we can say. Okay?
Yes, sir.
Yes, yes, yes. Which is given by our process, not defined by anyone. Which is given or defined by process, we can say. Which is actually what is happening with the process. That is voice
यार,
of
तरफ से
process,
3 लोग
right?
थे, दीक्षित साहब, हतकीरा साहब,
During the
Understand
process,
this? Yeah,
understand,
yeah,
या
because
एंड
the
yeah, yeah.
तो
variables
मेरे और
involved
दीक्षित
in the
साहब को
process
लगाया और सेकंड मैन को भी
Okay,
लगाना
okay, okay.
and
ठीक है,
So,
imitating.
चालू हो गया।
yeah, these
उसके
variations
बाद
all will
जो
come as like our process
मैंने
is
अपना नाम
speaking with our
अपना
team
नाम कर दिया,
members, management. Our process is speaking by giving some variations, right? By
सबके
giving some
सामने करो
variations in
ये
the
सभी।
output products. So that is voice of
हतकीरा आपको
process.
होगा, आप दोनों भी आ जाओ।
So before that, we will use some statistical method for that analyzing that variations. Then they will do
वाला ये काम
some corrections. Where we will do corrections? Where we will do corrections, actions.
स्टार्टिंग में काम बहुत है,
Yeah, right. We will take the action over here. Right?
हटाना वो बात की बात है, तो डिजाइनिंग करनी है,
So now it is
देना है,
clear how the system is
ड्राइंग
working,
चालू
right?
है, उसके बाद
Yes, sir.
Yeah,
पार्टी
yeah.
फाइनल
This
नहीं
is
है,
a basic system, but you need to understand what is VOP and what is VOC, right? Okay.
उनको तो सारा पका पकाया सामान चाहिए।
Okay, same things. What are the process? So process we mean all the combination of suppliers will be there, producers will be there, people will be there, input material. In this, maybe the things related to all these input materials are very important. Information about the performance, how the performance of the process is learned by doing the study, proper variability. All these things are very very important. Process parameters are very very important, like temperature, cycle time, feed. All these will define the output, how the part is. Again, same to how then we talk about actions, like forum actions. We need to take the action on the forum to improve our we can to reduce the variation and to improve the product quality, right? And one more thing, what is which is this one is good, or third is good, or fourth is good? Which one is good? Action on the process is good, or action on the output is good?
Action on the process.
Action on the process.
From the process.
Right.
आउटपुट अपने आप
See, action on the output still some of the industries are doing. What is that? There is a name for that.
That is the re-inspection.
Right. Inspection. That is inspection. Action is just scrapping. That is the action. Because already we are working on something like dead bodies. Postmortem we are doing. So we can just remove and we can throw it. Some of the part we can rework. Still it will create some waste, right? So the real-time monitoring of process with their output by using SPC, then taking on action on the process is very important, which is economical, right?
Right.
So, so same things, in a different name we can say prevention versus detection. So which one is better in this? In the case of product quality, yeah, prevention is better. So yeah.
Prevention.
Right. Still our detection activities are going on in some of the activity. We are not stopping detection, right?
So Nitin sir, could you please explain why prevention is better than detection?
Yeah. That is we are discussing, right? Same thing, na? You are talking about the previous, not previous slide, this slide, right? Yes. See, detection is something. See, after producing the part, just we are checking the part. Inspection, we can say. Inspection, maybe some of the areas we can say some are controlled by machines, some detection, but still part is produced, right? But inline detection will be very good. But after producing the part, keeping aside and doing the inspection, we cannot take a right decision because already we lost some parts. It will result in loss, right? So previously, in the past, the production of part, see, they will make and they will check the final product and they will screen out. That was happening. So then they will see whether they met specification or not. So it is like producing it first, keeping it aside, then checking. So there is a huge loss. So work is often checked, then recheck again 2 3 times. People will check. They will have doubt on the parts, entire parts. So there are very wasteful actually. So waste is everywhere. Waste will be there. Again, store material will be checking. There will be a containment action. Customer will be complaining. Some parts will be in the transport, transition or whatever it is. So it will be a huge waste. Some of the parts, some of the cases, they cannot rework also. So that in that case, that will be a huge loss, right? So unusable, it is much more effective to avoid the waste by not producing unusable product, or we can say producing the part within specification with prevention strategy, which is very good and sensible. That is very important, and making clear when there are issues with the process, making and giving us some sort of signal to the process that there is a variation going to happen. There is some sort of variation is there. So it is going to have, it is going to increase or something will happen. Some defects, some parts will get rejected. So when operator is doing the SPC right on the machine, for actually on the right time he is doing, he can correct. So he can correct, he can see there are some changes. So based on that, he can take the uh, action on the process. That is very important. By the way, we can prevent the defect, prevent the defect which is coming to waste, then ultimately loss to the company, right? So why do we need process control? Why prevention is very important instead of detection? You know, detection tolerates waste, detection tolerates waste, detection is always a waste. So prevention avoid that. Uh, that is very important, huh? Right?
Sir, my question is there. Control chart prevention or detection? What
It
data
is
provided?
prevention.
But actually
Control.
detecting
Yeah.
variation.
Yeah.
Detection then prevention.
It's prevention or detection?
It is prevention. See, what we can say, we are preventing the further defects, right? In SP, when we discuss about control chart, na, you're thinking something different. See, detection here, detection means just quality inspection. I am saying, what we do in quality inspection, we want to detect some defect. For that, we'll do only quality inspection, right?
No, I'm using some Pokayoke at machines.
Okay. So it's okay. Okay is like detection only. Sorry, that detection is entirely different. Huh? Okay detection. But that is done in the, see where you are doing. That is very important. No? That is very important, right? You are doing at the process. That is very important. If your okay is online, that is very good. You are preventing further defect. No? Right? But you are checking after all production. That is a waste. That is the meaning here, right?
But actually, I can check the output after processing.
Right. But how we are checking? The time is very important, na? When you after producing 100 parts you are checking, or after producing entire lot you are checking, that is very important. Here the prevention is, you will come to understand, you will have a clear idea when you see the control chart. Huh?
Okay, sir.
Okay, because in control chart we are not finding any defect part. We are not going to detect any defect part. We'll get a clarity in that discussion. Huh? Very good. Huh?
ये तो
Right?
फाइनल प्रोडक्ट होता है प्रिवेंशन में लिखा है इसने पहले
See, some of the terminologies are used in different ways in different areas. You cannot compare POKOK because POKOK there is prevention detection POKOKs, but POKOKs are very good, right? Because it is controlling the defects at the stage itself. It is stopping. So that is very good. I'm talking about an inspection, right? The wasteful activity, we can say. Some areas it is waste, some areas, some of the parameters customers are specifically asking for inspection. So we need to follow inspection, right? Still, how many are agree with me? Inspection is a wasteful activity or not? Inspection is a waste or not?
No. If I see in cost, it is waste. It's not non-value added process inspection.
Okay,
If
okay.
we get the good part at the machines, there is no need to do the inspection.
Yes, exactly that. Here, our process is how the process is improving. Based on that, we can at least reduce the inspection, right? Agree with me? Right?
Yeah.
Yeah. So we'll start with the basics of basic calculation, some basics related to SPC. Right.
क्या
Is my slide is moving now?
टिकट नहीं हुआ होगा 100%।
सर सर
No, it's not moving.
100% नहीं हुआ होगा।
Right.
इसका टिकट हो गया था लप्पू उसका,
Just a minute. My
वो
slide
मेरे
is
को बोला
moving.
तत्काल का टिकट नहीं हुआ और दूसरे दिन आ भी गया। गोली देने में साले सब
Okay, right. Sorry. So we'll start with the basic, right? See, no need to understand very deeply, but at least some of the parameters, how the calculations are being done, because it has been related to our control chart or SPC, CPK calculations. So there are some relations. So some basic understanding should be there. So specification limit, what is meant by specification limit? We'll discuss all these. Right.
Yeah, that is given by the customer.
Right.
You can't change
right,
this.
That is okay. There are what is meant by USL?
Upper specification limit.
Okay.
That is taken from the drawing.
Okay. And LSL for?
Lower.
Okay. Right. This is called as specification limits. One more thing is there. What is that? What is this?
UCL, HCL.
Lower control.
Upper control limit, lower control limit.
Okay. Right. So there are control limits. You can see the control limits. There will be a solid line on the control chart graph. You can see that is control specification limit. Control limits in detail we will discuss. These are calculated from where it is calculated. That is very important. This is given by who?
Customer. Customer side.
Now you tell which is related to VOC and which is related to VOP.
USL is VOC and UCL is VOP.
And UCL is
VOP.
Okay. Everyone agree with me for this?
voice of
What the understanding? What the understanding?
बिल्कुल
I hope this is clear to all, right?
Sir.
Yeah. If you have some doubt, still maybe 70% you are clear, because our control limits are set by the process, not by the customer. Right?
Right, sir.
Just one more basic example I will just next for discussion. Just see, this is a process.
कॉन्फ्रेंस में कुछ
कॉन्फ्रेंस में है आपको चलना होगा अरे वो प्लानिंग
क्या
अकाउंट वालों को
अकाउंट्स वालों ने बुलाया है
कौन बुलाया था आपको भी बुलाया होगा किया है चलो आपके साथ
This is UCL. Sorry.
वो लिफाफे हैं
मिश्रा जी ने
लिफाफे दे मिश्रा के बोलते हैं नहीं फिर तो सही ना सही दो आदमी को बुलाया है मोटे तो ये आना पड़ेगा एक्स्ट्रा लिफाफा का तो हम यहीं से ले जाकर से दिलवा लेंगे
What is this? This is mean, right? And this is UCL. We can say 1 minute. See, this is UCL, right? And this is LCL, right? Agree with me, all team? With me?
The upper is UCL and lower is LCL.
Okay, okay. Yeah. Which is defined by, this is UCL, we can say this is UCL, and this is LCL, which is defined by our process only. Right? So one of the parts, when we start measuring the readings, one of the parts is going here, one part is here, and one part is going outside. What is that? That part is okay or not okay? Is it a good part or bad?
Part is okay as per the specification, but it's crossed the control limit. That means we need to make it at mean.
Okay, what's your good name? What's your good name?
Krishna Kumar. I am from Saddle Perfect Stream.
Okay, right. So any other answer? This part is okay or not okay? This part. Tata Auto comments. Any answer?
If it is not crossing the USL, then it's okay.
Yeah. What's the good name?
Amar Shankar.
Okay, Amar Shankar. You're from Tata Auto Components. Which company?
Saddle Perfect Stream.
Okay. Okay. Tough team. What's your answer? Is this part is okay or not okay?
If it is come under USL, then it is okay. If not, then it is okay.
Okay, you are agreeing with the same opinion, right? Okay. So there is no further answer. This is based on LSL or based on specification limit. We can decide whether it's okay or not okay. But we cannot say it is as a rejection. Okay, agree with me. There is no different opinion, right?
Right.
If there is no different opinion, that will be very good. Right? But without how many people are understanding and saying, that is very much important, right? So we'll come to see all these how these will be aligned with the control chart principles. We'll see, right? And there is always one more thing we use is distribution. Control limits will be there, and specification limits also in between we will be using, which is LSL, USL. control limits, we use LCL, UCL, and distribution. Distribution is something, the spread of data, how the data is spread, how the data is spread. It may be like this, or maybe like this. Some areas it will be shifted, some areas will be like this. So this is distribution of data. Don't get confused, just how the data is distributed over a period of time, right? So it has been we can say, in data distribution also there are 3 points to be noted. One is location, and other thing is spread, and one more thing is shape. There are 3 things to be analyzed for any data. See, one is this location, that is location. What is the process mean? This line is called as, what is this? This center line of this any process. See, we take
Process mean.
yeah, this is called as process mean. We use it as X bar. Many areas we use as X bar. X bar, or some areas maybe X double bar also, right? Based on, don't worry about what are the symbols used, but understanding this mean, process mean. This is process mean, we can say. This is process mean, we can say, right? And about the spread, this is the, we can say, this is the spread, how the data is spread, or we can say how the data is spreading. Then shape, how the shape is there. Yes, this is the shape. So these 3 things are just related to distribution of data. So location, spread, and shape, right? So measuring, for measuring all these, there are some terms also that we will come to see in coming slides. See, we always use this mean. So keep in mind, mean is used, right? Mean is used everywhere, and standard deviation also used. So standard deviation is to measure spread. So the spread is measured by standard deviation. Whatever the spread, you can say how the data is spreading. All these we can say, we can divide this into small portions of variations. So one portion is called as sigma. So that is standard deviation. Okay, right? And we use ratio only, part spread only. For shape, there are different of distributions in statistics. So in this SPC, consider normal distribution only. So SPC is fully based on normal distribution. There are other distributions, so no need to get into that. Only normal distribution will touch what is normal distribution. So normal distribution is the principle behind control charts.
Sir,
Clear?
sometimes I hear that ND, normal distribution, and constant distribution. What exactly JD?
Johnson's distribution is Johnson's maybe transformation. Exactly, Johnson's distribution is not there. There is some transformation, we can say, that is used for non-normal data transformation.
Actually, I use QDAS software that is showing JD and ND.
Okay. Right. Which software you using?
Sorry?
What is the software name?
QDAS.
QDAS. Okay. So here, how many team members are using Minitab?
I used in my last organization the Minitab.
Okay.
But I am not using. But yes, I am familiar with the Minitab.
Okay. Jodi Katki, which industry?
Minitab was used in Bosch.
Okay, right. Now currently anyone is using Minitab?
Yes, sir. From paraphrasing.
From which industry? Please, I couldn't get you. Yeah, please speak up. Please. I'm not able to hear you. Yeah, see, Minitab is the most commonly used software. Even you can download maybe 14-day some trial versions, and you can learn at least basics. Huh? Right? It is very simple. Just you can learn at least basics. You just put the data, automatically the graphs, everything will be generated. Right? Before that,
Second link was for Minitab download.
There is no specific link that is based on the registration. You need to register in that website. Yeah? You can just Google out. In that mini tab, there is a website. You need to register your name and email ID. Then 14-day trial version you can download. 14 days. Huh? And afterwards, it will be payable.
Okay, sir.
At least for 14 days, you can use that. Before that, I request all the team members, still you need to do at least 2-3 times in paper. Then only you will understand. So that is why I kept at least one exercise on control chart, how we are doing. Huh? So that is very important. Just learn and apply also very important. Because directly if you jump into a mini tab, you cannot learn properly, right? Okay. We'll start with the basics of statistics. Okay. So what is meant by population? Population is entire set of data, right? Entire set we can call it as population. Full data we are collecting entire data, that is called as population. We are taking only some samples, small number of items we are taking from here and there for the judgment, for the study. That is called as sample. And sample size or subgroup size, we can say it is the number of samples, we can say number of items in a subgroup. Okay, so I will give a just like an example. So you see, in now what is most of the things has been changed. See, if you want to buy see, your mother or maybe father will be doing, when they go to purchase for any rice, they will just buy 2-3 rice, and they will identify how the quality of rice. I don't know how much effective is that, but they will do the same thing. Agree with me?
Sir.
Yes.
Yeah.
What is he doing?
He's just checking which rice is better.
Sample inspection.
Yeah. Yeah, checking, that is clear. Well, we said that it is called a sample inspection, right? It is sample inspection he is doing, right?
Right.
Right. That may not be properly planned, but still he does. He may be checking one rice, maybe 3-4 rice, or he may be taking 5 rice at a time and checking, right? But in SPC, same thing we follow in a different fixed manner. Huh? We will fix all these standards, how to take, how many samples we need to take. So so he is not going to check. See, he is not going to check entire bag of rice.
It's not possible to check entire bag of rice.
Right. But in production case, it is possible, right? Agree with me? If you are producing 200 numbers, you can put 3-4 manpower and put
Yes.
people to right. But still there is a
But
waste, right?
not required.
Right. Not required. Right.
Take decision on the 100% segregation or not.
Okay. Right. All depends on how the process is behaving, right? Right. See, just an example for this. See, this is a rice bag. So he may take 2-3 samples. Just I'm only selecting only this. So 3 samples is taken. So there will be number of rice. So what is the number of samples? 3. Right? Rice. Okay, sorry. Right. In this, there may be 100 rice or something. Just for an example, I am taking 100. What is this 100? What is this 100?
Sample size. It's the sample size. 100 parts.
Yeah.
3 samples.
Yeah. This is sample size.
Yes.
Very, yeah. All others. Affecting is clear. Yeah. So Noida Power Limited, someone want to speak anything? Are you clear? What is population? What is sample? What is sample size?
Sample size.
Sample size means number of pieces in a sample, we can say. See, he is just measuring, he is just counting how many samples are there. Right? If you take only 5 rices for checking, the sample size will be 5. Okay? This is the point. Okay? Only 5 is taken for inspection. That is sample size. Right?
Yes, sir.
Okay. So everyone with me, clear about this? Yeah, please speak up.
Yes, sir.
Naveen?
Yes, sir.
Yes. Okay, then we can go ahead. Just find out this. What is the number of samples and what is the subgroup size? In this, you can consider only the circled items only. Circled items you can see. Just put your answer in chat box. I want to see. Put your answer in chat box. I requesting all to put their answers. Understand what is what is the sorry, I will share same. Yeah. What is the sample? What is the number of samples? Please put in the chat box, and what is the number of subgroup size also? You can put it in the chat box. Please message in the chat box, Amar.
Number of samples.
Don't discuss, just share. I need to see how you are understanding this.
सैंपल तो एक ही है, सब लोग साइज सेम है।
ये सैंपल हमारे साथ हो गए ना, और फिर तो पूरा हो गया। नंबर ऑफ सैंपल बोला तो साथ ही है ना।
सब ग्रुप
एक बार सैंपल लिया इसमें।
सैंपल ये लाल वाला गोला क्या है?
ऑपरेशन दिखा रहा है, वो एक शिफ्ट का है।
Just to see the circle only, 2 circle only. Inside how much is that you need to see.
2 सैंपल हो गए, सब ग्रुप साइज 7 है।
Okay.
नंबर ऑफ सैंपल नहीं, इसमें तो 7 है ना। 2 सैंपल।
Yeah. Please mute.
दो बनाए ना इसने, 2।
Yeah, tell me now. You can speak up. Now you can speak up also. So in this, there are how many samples are there? How many samples are considered?
बिल्कुल लिखा नहीं है,
लिखा होगा, दिखाई देता है।
Mr. Christian, how many samples are there? Yeah. Your voice is very low. Okay, right.
Seven
Shivkumar.
samples.
Yeah. No. Christian, it's not 7 samples.
2 samples.
Okay, it is only 2 sample. Christian, please understand. You are
Sample
understanding?
size.
Okay. The sample size you can say in 186, 187, huh? Any other answer, Mr.
Sir,
Sundar?
two
Are you there?
Both,
Sundar, are you there?
those samples, subgroup size 7.
7.
6 oblique 7.
इसका चैट तो आता है इसमें।
अरे अनम्यूट कर दो ना।
नहीं मैं कहा चैट से लिख देते ना।
चैट तो
Yeah. Tell me. Anyone wants to speak? Hello? Yeah. What is the number of, what is the sample size of red color circle?
2 number of samples.
First one.
6 samples.
Yeah, I'm not getting. Please speak up. You are not audible properly. Your voice is very low.
Sample size is 6 under red color circle.
6 or 7.
Okay, very good. And number of samples is 2, right?
Yes.
Okay.
7.
So this is clear to all.
7.
Okay, and we can say all these entire data is population, right? This is population, and these 2 are samples. Inside the numbers are called sample size or subgroup size, we can say. Okay.
Sir, please describe the subgroup size in detail. We did not understand the subgroup size.
See, this is something, some product is there. So we are taking some samples. We are taking some of the samples only. First of all, we'll take only 7 samples. So you can see this is a set of sample he has taken. In that 7 parts are checked. That is 7 is sample size. Okay. You understand previous example or not? Why you're asking? You should have asked before. That is something more interesting. That rice example you clear, na?
Yeah. Rice example is clear for sample size, but subgroup size we need to understand.
Sample size and subgroup size are both are same. Huh?
Okay,
No,
both are
sir.
same.
It will be different. Na? If I understand subgroup size, in a subgroup we have the sample number of samples. In one group we have the total number of samples. If 7 subgroups are there, it means 14 number of parts are there to be checked. That is my understanding. If I talk about the quantity of the parts to be checked in 7 subgroups.
Yeah. I'm not getting what you're saying. See,
It is like there is a 2 samples. In first samples there is a 6 sample size, and in second samples there is a 7. Number of samples are 7.
Yeah. Subgroup size only better to call as subgroup size. We can call it as better, because what we get now in some because some of the areas, see, based on how many samples we need to take for study. You know how many samples we need to take. Now here only 2 are taken. Some people will take 3. Some these are all samples. We call it as samples, right? We can call it as later number of samples also. But when you go and study, this is group size. This is 1, 2, 3, 4, 5. In that, how many products are there? We can say. How many individual products are there? We can say, right? Okay. In especially the coming slides we will be discussing. samples constant subgroup size and different subgroup size also. Here we taken two samples with constant subgroup, different subgroups.
Sir,
Okay. Yeah. Tell me.
in that populations, six samples.
Uh-huh. Please, your audio is very low. Yeah.
क्या
So please make your mic. As some of the people are talking, I'm not able to hear you properly. Right? Okay, this is clear. Here we can see these are the numbers. Right? Okay, we will go to variation. We will see the variation again. What is variation? Again, that amount of variation. Change in any will be a difference in product amount of we can say it may be quality. There are different. There are no two products will be similar. No two products will be similar. There will be a slight variation. Which variation is the enemy of the quality. Variation is enemy of quality. And variation can be of two types. What is that? What are the two types of variation? Yeah. Please speak up. You already know what is the two types of variation. One is common causes and assignable causes. With me, all members.
Yes, sir.
Yeah, right.
Sir, common cause is the part to part variation. Within 1 to 2 micron.
No need to think. There is one more name to common cause. One more name is there.
Our coaching position is also one example of common cause. Every time our hands not move the index.
Okay, right. And there is one more name for assignable cause also.
And assignable, that means out of tolerance one.
Okay, right. Oh yeah, someone was saying that. Yeah, exactly right. That is special cause, right? Okay. Common causes we can call as natural variation also, right? Okay. So take just an example. See, one person wants to drive. He daily used to go to work by taking a car or driving. So he cannot reach the office always at the same time, right? If 9 o'clock is the reporting time, there will be always some changes in his reporting time, right? Or punching time, whatever it is. Right? In this case, we consider only he going to his office by driving a car. Right? So in this case, so what are the special causes? What we can say just before that, we'll explain what is common causes and what is assignable causes or special causes. Common causes and special causes I will explain. See, common causes are which are very inherent with the process, very difficult to we can say very detect. That is all common causes we can say. Special causes are something which can be very easily detectable and it will give some very high impact or changes in the output, we can say. So by giving examples, we will understand very deeply about these two causes. In the case of so if someone wants to go to OT drive, so some days he may go, he may reach very early. Some days he may get delayed his reporting time late also because of different reasons, and there will be huge variations for some people. There will not be variation for some other members. So what are the reasons in this case? Just give me what are the special courses if someone is going by for this example. Just tell me what are the special courses for this.
इसमें किसी ने कॉन्ट्रैक्ट बनाया होगा, किसी ने कुछ बना के ब्लॉक कर
He
दिया।
may get late. He may
Vehicle breakdown is
vehicle. What you going to say?
special course.
Vehicle. I didn't hear you fully. Vehicle and after what did you say?
Vehicle breakdown or vehicle repair.
आइटम जो जॉब कोड है, जॉब
Okay. Yeah, right.
Due to traffic,
Traffic interruption,
due to traffic
unexpected.
reason, there.
Yes. There is also a special course. Yeah.
नहीं इन्वेंटरी कॉन्ट्रैक्ट भी सारा
Maybe some of the traffic may take more than maybe 30 minutes. Yeah, breakdown. Abnormal traffic we can say. Some normal traffic we cannot consider it, right? Because it is always there, right? Okay. Now what are the common causes?
Common causes are wear and tear of the tools.
Okay, right. I'm just relate with the example and say. Yeah. For this example, what may be the common causes? Just when we go to office, there may be some natural variation also. No? The person is very much punctual also. There will be. Yeah. Anyone wants to speak? Who is that?
Hello.
Yeah. Tell me. If someone is speaking in phone or something else, please mute and keep it there. Yeah. Any answer for common causes?
Speed variation. Common causes.
Maybe speed may be slow, bit slow, but not that level we can say, right? Maybe late. He left the home maybe late by 2-3 minutes, right?
Extra signal, so we can consider.
Yeah. So those things we can consider, right? Yeah. Okay. So in this, some of the example is given and like wind speed and all. It is very difficult to we can say may or may not it contribute. We cannot say maybe green light. Yes, he stayed over there like signal, driving speed, right? The number of cars, something we can say time leaving the office very maybe 2-3 minutes, not much, not so much. Whatever the high impact or very drastic changes like some of the critical events like some accident has happened, some traffic police has pulled over for overspeeding or something, then he got delayed, some then rain has come or something, then mechanical issues or breakdown someone has already said. So there will be some variations, okay, right? So you can say he always reach by almost here you can see we can say 12 minutes. So see here is the process is like the total driving time we can say. So here 12 is the mean, right?
कोड दे रहे नॉन जोशी
Agree with me? 12 minutes is the
नॉन जोशी वाला
12 minutes maybe we can say he is reaching around 8:55 or something. Then from 8:55 onwards he may come 12 minutes early or 12 minutes late also, right? Sorry, 2 minutes based on 2 minutes. Yeah, 2 minutes he may come. See, It will be 10 minutes.
सारे थे वहाँ पे
Or it
10
may
to
be
14.
14 also. Huh? Or it may be 16 also. Huh? Right? It may be 16 also.
वही कर रहा हूँ जोशी नॉन जोशी में वो
Right? It may be 8 also.
सारे वैलिड हो गए हैं
So
वो
this
भी डिलीट नहीं होगा
this gap is called as
करना है
standard deviation. We will give,
देखना है वो
we will touch this topic. Just I am giving because this example is
नहीं है तो ठीक
you can very easily correlate with this standard deviation. Huh?
सारे बंद करेंगे
So 2 minutes you can say
बंद करेंगे
here 2 minutes
पता
is
है वो
something we
चलना वो
called as
क्या वो तो
standard deviation. This is a variation he is maintaining. So this variation is called as 2 minutes variation. Okay?
हर के सब थे होता
And this mean of 12 minutes is given by the process, right?
अब तो सारा तो ऑक्सीजन का ही है वो जोशी
Is given by that process, the process of driving, right?
अलग अलग हमारे सेक्शन के
Agree with me?
सेक्शन के हिसाब से ही है
We discussed the same thing, right?
नहीं हम सब सेक्शन दे
सेक्शन
So it is called as voice of process. You understand? You can correlate with the previous definitions.
विशेष साहब आए थे कि यार 3 दिन के लिए मैंने ये कमरा बुक कर रखा था तुम लोग यहाँ पे
Is it clear?
Yes, sir. Yes.
मैं बुक
Yes. Okay.
Yes, sir.
Yeah.
पिछले वालों ने कितना पैसा दे रखा है वो किराया पता नहीं कितने सालों के लिए फ्री हो रखा है
So in this case, one more
पर है हमारे नाम
question.
पर
If the variation is very high,
अच्छा तो उनको
it is
देना
only 2 minutes. If the variation is 10 minutes means 15 minutes he may get very late,
बिजली
right?
कर रहा होगा फ्री में
Right? He may reach at 9:45 also.
Sir, this would be special
कमा
cost.
के दे रहे हैं
हाँ, right,
The
right.
tire
Right.
punctured or some
कमा के दे रहे
accident happened, something like that.
Yes, exactly. There will be some special causes.
पिछले
But
सारे
still,
नंबर में 10
just to understand,
हमने इस बार
if the standard deviation is high, the variation also will be very high. Agree with me?
Yes, sir.
Yes. Okay.
My mom got dead.
एक उसमें खर्चे का था कि नॉन जोशी जोशी के जो
See, again we will discuss.
हम
Mr. Mohapatra,
कर
are you
देंगे
able to join or what is the issue? You are sending the request a number of times. Please make
तो हमें
sure your
खर्चा
net
अलाउड
is
हुआ है जोशी में
more
मैं
strength because if you don't have the proper strength
यूजर
of the internet, there will be an issue. It's
जनरेशन में
getting
ट्रांसफर
disturbed.
करना है या मेंटेनेंस ट्रांसफर करना वो आप
Mohapatra?
यूजर को दे दो
Yeah.
बोले नहीं रस्तों साहब बोले नहीं यार ऐसे कैसे हो जाएगा यूजर कैसे
So again, there are common cause variation exits in every process. It can be reduced by process improvement activities, but it cannot be
अगर
eliminated.
किसी
Rightly, I discussed. No? So
किसी में कम हो रहा
these
है
are natural
वही उधर
causes.
सीधे
We
ट्रांसफर
cannot eliminate all these
लेकर करा हुआ
variations.
ये क्या मतलब
Right? These are inherent in
एक्स
the
अमाउंट
process.
सेक्शन
That
कर
is
दिया
called
आपने
as
एक्स अमाउंट पे अपना
common
चलते
causes.
रहेगा
And assignable causes, which is unnatural in a process, it should be identified and addressed. Okay?
वो
It
अपना
can be very
पता
easily
लग जाएगा
addressed.
अच्छा किया ये
Right?
अच्छा किया
उनके पास खेलने के लिए कुछ
Right. Agree with me?
काम खत्म हो जाएगा तुम सर्टिफिकेट पे हाथ में ले लो
हाँ, कोई
Yeah.
मिल जाएगी नहीं तो
Yeah.
पूछेगा नहीं सही से वो कम पूछ रहा है
सही पकड़े हैं
मतलब खाम खा एक रंगा लगा रखा है
अभी ये बता कोड जो खुलता
So all are clear about these variations, right? Both the variations, right?
कोई मतलब है
वो खो जाता है कागज सर
हाँ है ये
ट्रैकिंग में
See,
कागज
same example, you can say if it is if the person reports to office very late, you can see the variation will be very high,
हम भी कर रहे हैं
हम भी भूल जाते हैं
right?
किसी आदमी का असाइनमेंट ही नहीं है कि वही इसका काम है ये
ऑक्सीजन कोड आ गया भाई ये सर ऑक्सीजन कोड आ गया सर रॉ एक्सलाइजेशन
Just a minute. This person is facing some issues with, I think, joining. Mr. Mohapatra, are you there?
मोहपत्रा हाँ मोहपत्रा चले गए
सो गया वो भी बताने वाला ही नहीं है, इंटरेक्टिव है वैसे सारा। हमारे पे तो आएगा नहीं। किसको किसको भेजा है? हाँ ओएस ऑक्सीजन एस सीजन और हाँ सीजन है, लेकिन सीजन का भी कोड दिया नहीं है और उसमें ओएस अंडरस्कोर जे तो जीओसी अंडरस्कोर एन नॉन जीओसी।
अच्छा अभी एक चीज देखो, ये कॉस्ट सेंटर बना दिया इन्होंने, अब ट्रैकिंग आईडी का काम खत्म।
हाँ
अब ट्रैकिंग आईडी का काम खत्म। अब कॉस्ट सेंटर पे
So up to now it is clear.
कैसे होगी?
कॉस्ट सेंटर नहीं है,
ये कॉस्ट सेंटर
ये आईओज है।
Yeah.
इंटरनल ऑर्डर में डालना आपको ये।
तो कह रहे हैं ट्रैकिंग आईडी में अभी डालते थे, आप ट्रैकिंग आईडी में डालते थे। ट्रैकिंग आईडी से आप कॉस्ट निकालते
नहीं, हम तो इंटरनल ऑर्डर में डालते हैं, ट्रैकिंग आईडी में डाल नहीं रहे हम।
So we'll just we'll have some questions, right? Just what are the things we learned? We will have just a summary.
तो उसमें वो पूछता नहीं।
So who was started was called as a father of we can say control chart or SPC.
खर्चा निकल जाता है
कैसे?
है ऑप्शन है उसमें।
ट्रैकिंग आईडी से निकल रहा था, इंटरनल ऑर्डर से नहीं।
What is his name?
Walter Sheep.
Edward Deming. Yeah, Deming. See, Shivart has started, then Deming has looked into. We can say, yeah. Right. Okay, right. So, prevention or detection, which is better in the case of SPC?
Prevention.
Okay, very good.
MIS जनरेट होगी डेली बेसिस पर।
MIS तो बाद की बात है।
नहीं, कितना खर्चा आपने किस कोड में किया?
Okay, what are the how many quality tools are there?
7 quality tools are there.
It is a 6. Okay.
6 7.
6. It is 6. Okay. Okay.
किसी ने बोल रखा
See, 7 is this is quality core tools defined by who?
क्वालिटी कॉल है, क्वालिटी कॉल है, करेक्शन प्रिवेंशन कर रहा है।
हाँ। So which edition of SPC is used?
Second edition.
Okay, very good.
हाँ, मेरे को नहीं आता।
बिल्कुल पसंद नहीं है। क्लासरूम होना चाहिए 1 to मतलब
I think someone is saying 7. That is 7 QC tools or something. Don't that is different, huh?
और ये जो सैप तो फेल होने के कारण भी 6 महीने ऑनलाइन जो चला है।
So in this case, that example related to the the employee driving to the office, and if he's getting delayed, we can say 8 o'clock to 10 o'clock, there is will be a huge variation, right? There will be a huge variation in his total duration. Agree with me? Right? So 9 o'clock we can say 9 o'clock is reporting time. So in this case, this 9 o'clock is the reporting time, right? So what is this 9? What is this 9?
Mean.
It's mean. No. It is provided by the time 9 is provided by someone.
Specification limit.
Yeah. Very good. Yeah. Please speak. The answer is
एक वाले में 2 डिवाइस अगल-बगल खोल रखी है, इसीलिए एक को आ रही है।
You are sitting in the conference hall, your voice is having some echoes.
दो डिवाइस खोल रखी है।
I am not able to hear you properly, huh?
इसने इसलिए इसको म्यूट कर दिया, इसने हाथ दिखा रहा है कि भाई मेरे को बोलने दे।
Yeah. Tell me. See, in this case, his process mean maybe it may be 8:30. Understand? 8:30. Huh? But this is given by someone else saying, no? This is given by company. Company is given the reporting time as 9 o'clock. So company is customer. We can say as customer, right? Agree with me?
Yes, sir.
Now I've given the hints. I've given the clues. Now tell me what is that? 9 o'clock.
Minimum specification.
It's the
Specification.
Right. Yes. One more going to be added.
Standard
Yeah.
time.
Yeah, standard time, that's okay.
Specification.
Specification also okay.
Customer
One more.
Voice of customer.
Voice of customer, that is a very good answer. That is also not fully correct. I am expecting one more answer. That is very much related to this line. Again, I am giving the clue.
This is the process mean.
No.
Center of the process.
Not center of the process. That is called as target.
Specification.
Yeah, center specification you call it, but target mean, right? Yeah. That is called as target mean. Huh?
Correct.
Yeah. Everyone clear?
क्या समझा रहा है?
Everyone is clear about this?
Yes, sir.
This is target mean, we can say. This is not this, but the process we can see. Just I will remove all these again. See,
चलो टारगेट मीन है,
if the person is
वेरिएशन तो है।
there is lot of variation. The person we can say like this. His variation, the line is here. Or maybe late. We can say once again. I will draw again. It will do it only.
Why is this Dale mouth you are making shape, na?
No, what you are saying?
I'm saying you are showing on the graph the Dale mouth shape. Why it is like that?
You are talking about the shape, You are talking about the shape, right? Bell shape, right?
Yes, why it is like that?
Okay. Yeah. We'll come to that. See, we are saying that to understand, if you understand here, we can skip some of the slides because no need to explain entirely detail. You will be understanding everything over here, right? See, here, because that person is coming very late and his process mean is something 9:30. I'm changing some calculations,
हेलो, ड्राइंग
But maybe company will be allowing only this much. How much time company will allow? Maybe 8:45 to, right? 15 minutes, right? Agree with me?
Yes, sir.
Yes. Yeah, in this you tell me what is the process mean, what is the target mean, you can say.
Target mean is 9. And process mean is 9:30.
Yeah, exactly right. A and B, right?
Correct.
So in this you can see our target is A to make the process to fit into A, but our process is having lot of variations and it has been shifted. Right? Mean of the process has been shifted. So it will result in lot of quality issues, lot of delays. He will be coming very late. Right? Already his mean is set at 9:30. He may come 9:45. He may come 10 o'clock also. So that is called a impact of variation is if the mean of the process is shifted from the target, there will be a huge variation. Right? Yeah. Now again we come to
special causes.
Yeah. Tell me what you want to know.
It is because of special causes.
Right. It may be special causes, right? It may be special causes.
And that can be adjusted or removed by taking action.
Yes. Then the B will come near to the A, right? That is the, yeah. So for that, we need to take all these actions. Yeah, very good understanding, no? With me, very interesting, or how you are, it's going up? All the members I'm asking. Because I want everyone to understand what is the basic, right? All with me?
Yes.
What is, yeah. What is, I told the process mean is defined by voice of process. Voice of the process through variations, different variations. Whenever he comes to how here he is coming to the office, there are different variations around, different causes of variation. So it will result lot of variations in the product or output. What in this case is time, reaching the time, the total duration time is having a lot of variation because of different parameters, different causes. Special causes will be there, natural common causes also will be there, right? So our intention is to make the process close to the target, right? So special causes also called as random causes. Also, you can see there are three names used. 2 to 3 names are used already. Natural causes also we can say, random causes, common causes. Don't get confused. Assignable causes and special causes also same. It accounts for, special causes accounts for 5 to 15 quality issues. So it can be removed from the process directly. Again, common causes are very high. Almost 95% of the problems are related to common causes. It will be the noise within the process. It will be very typical to understand, and we can say to exist in, and it exists in process. It can be reduced. Special causes are very easily identifiable, and we can easily, we can say, remove that. See, someone was asking about the this bell curve, right? Distribution. Bell curve, or what we call it as distribution. So, what you need to do, if you arrange all your data in a histogram and draw, see here you can see the histogram. My pointer is not coming. See, this is histogram. You can say this is histogram. Okay. So if you arrange all your data, this will be this in some more detail. It will be covered in normal distribution. There is a slide related to normal distribution, right? Because of normal distribution, it is shown as bell curve. So in this case, in this distribution, data will be symmetrically, equally, we can say left side of mean and right side of mean, it will be equally distributed, right?
Okay, sir.
Clear. Simple things. Some we can, with some of the things are defined by statistics, based on statistics principle. So there are some assumptions. So that is called as normal distribution. So we'll touch upon a normal distribution in the coming slide also. So here you can see there are we discussed about parts going above the control limit. So you can see here is the control limit. Here is the control limits. So most of the special courses region will be above the, we can say above the upper control limit or below the lower control limit. Because of this, there will be a variation. So in this case, our distribution of data will be this way. This much variation will be there. When we eliminate all these special codes, when we eliminate all, we taken a lot of actions, then what will happen? It will come very small, right? Then we are left out with, what is that? Common cause. With me?
99%.
Yeah, all. I'm asking all. Understand?
Yes, sir.
Yes, sir.
Means the driver is coming like he has taken action to all the special courses, most of the special courses. He is doing some breakdown of vehicle is happened. So he may not be doing his maybe services regularly. Then he started servicing his vehicle properly, and he made some notes of the timing of service also. He maintained oil level, everything. So he maintained his vehicle properly. So he has eliminated one of the special courses. So by the way, most of the, in that case, some of the special courses he can control, some of the special courses he cannot control. So maybe leaving the home very early, that also maybe some of the 15 minutes early or something. So by the way, he can at least reduce the variations. Some of the actions can be taken. So in the case of production, special courses, like lot of special courses will be there. So, so tell me, what are the special courses examples related to any production activities? Special courses.
Special
Could be breakdown.
Breakdown.
Abnormal conditions are special causes, power cut, air leakage, like that, or breakdown. Because of that, defect can be produced if air process, air pressure is dropped suddenly. No?
Right, right. Yeah, easily detectable, right? Any other example?
Tool breakage.
Tool breakage.
Yeah, tool breakage. Very good, very good. Yeah. Any other example? I need some more examples, some more practical examples.
Shift changeover.
Blackout होता है उसको?
Yeah, shift changeover. Right. Related to man.
हम तो blackout बोलते हैं.
Right.
New manpower.
Unskilled manpower required at machines.
Yeah, skill, new manpower, no training.
ये अपने डिजाइन में पॉइंट कर लेगा डिमांड मिला.
Variation in raw material.
Yeah, very good. Raw material. Yeah, incoming material is
Wrong material selections that also wrong parameter selections that are also special causes.
Okay. Yeah. Parameter, process parameters set up, right? Okay. Okay, agree with me. Yeah. So you agree all these special courses, when we eliminate all these special courses, the variation will come down. So we are left with only common courses, right?
Right.
Yes. So from here we need to improve again. So what we need to do?
My point is, the cause of variation is also this is due to the weather also.
Yeah, weather also we can consider based on the product what we manufacture,
Because we are working in the sugar industry, so
Okay.
there is a change of weather is affected our this process.
Right. In your case, you can consider as a process parameter, right?
That's why environment is considered for the variation.
Okay, okay, right. Now my question is, we need to improve from this special courses we have done. We have taken some actions. We are eliminated special courses. Huh? We worked on some actions, and then now we are the process is like this. Now again, what we need to improve the process. What we need to do?
To remove common causes.
We need to remove the common causes also. We should not remove, but we can reduce the duration.
Okay.
And the center.
स्पेशल कॉजेस तो हटा दिया, कॉमन कॉजेस हटा दिया।
If it is not coming at the target line.
Okay. Yeah. Is it very easy to improve from here to the next level?
Sorry?
It will be very difficult, or it will be easy for improving from
No, it's not easy. It's not easy. It needs analysis, and we need to define the correct root cause. Then it can be improved.
Okay, very good. So agree. So everyone agree with the opinion shared by is, yeah.
Yes, I agree.
Agree, right? So to remove and improve from this level to next level by taking action on common causes are very important. So from this stage, what we can say, we are moving the process to the next level. Huh? We are improving our process, right? By removing common causes also. And common causes are very difficult to detect and difficult to take actions on common causes. It will be systematic actions are very much required on common cause variation. Some management decisions, management control is required for common cause variation. Special causes, most of the special cause variation, some of the actions can be taken by the operator, team leader, supervisor. They can take the actions, right? So going to the inside of the control limits, there will be the level of root causes. We can say the strength of the root causes will be very much high when we go to common causes, because there are multiple small parameters which will be impacting the product output, right? See, these are some of the examples. You can see here there is a special course. You can see there is a special course. That is why the process is shifting here. The process is shifting here. This is target. This we can say as target. This is the target mean. From here we need to reach. Because of the special course, there will be a lot of variations. Okay. Here this process is stable, or we can say this is one. Which process is stable?
One.
Common causes.
Yeah. One. We should say one, right?
One.
Yeah. Here only common causes are there, and process is stable over the time, right? Here there are a lot of changes, right? So common causes, again some notes related to common causes. These are the variations within the process that has a stable and repeatable distribution. So it will be stable, but still there are some sort of variations. They are like chance causes. If common causes are present and do not change, output of the product process will be predictable. So we can predict common causes are there. It's somewhat it's okay. We can call it as in statistical control. We say no, it is the process is not in statistical control. If the common causes are there, the special causes has been removed, we can say process is in control. Okay. Clear? Okay, if special causes are present, the process output also not stable, as we see in the previous diagram. The output may not be stable, right? Okay. So again, some definitions about what is in control, what is out of control. So out of control is something where special cause is existing, right? You can see out of control means process there are special causes. If special causes are removed, we can say common causes only exist. Process is in control and it is stable and predictable. This is very important. We can predict. But in the case of special causes, it cannot be. We cannot predict properly. There will be very unstable changes, and any time the process will be out of control. That is why we need to attack on special causes first. Agree with me? Yeah. Which causes we need to address first? Yeah, special causes. Okay. See this diagram what we discussed. This is fully SPC here. Entire SPC theory is here. If you understand this, you will get a clarity. You can relate with this. How variations are reducing, how we are changing all these control limits, how we are setting the control limits, how we are changing, how we are improving, our process. That is based on improving all our CPK, PPK values will also please tell. If we keep on improving the process by reducing the variations, CPK, PPK values will increase or decrease?
उसका दायरा कम है और स्टेबिलिटी ज्यादा है.
Yeah, are you there? Please speak up.
रिसर्च के कारण केवल 5%
Could you please repeat the question, sir?
We are taking a lot of actions on the process. We are continuously improving the process. So what will happen to CPK and PPK values?
It will increase.
It will increase. Okay.
Decrease the
Yeah. So we think decreasing. You agree with me? Decreasing, right?
We improve, then it's increasing.
Okay. Okay. Any other answer? Increasing or decreasing?
Increasing.
Everyone agrees with the same answer?
They are the part of the system.
See, it will be always increasing only, right? Someone was saying decreasing. That is not right. It will be always increasing. So by taking action on the variations, the sigma standard deviation is getting decreased. So variation is very less. So CPK value, PPK value will be improving or increasing, right? Clear? So again, one more example you can see. Okay, this process you can see. First process is out of control. You can see this process is called as out of control. But why? Because what's the reason it's called as out of control? What's the reason? Okay. There are some actions taken, and you can see the process mean is nearly equal with the target mean, and it is called as in control. And in control means still there are some causes available in this process. What is that? Common causes. Yeah. Please speak. Yeah, please answer, right? So in this you can see, we are talking about capability over here. Stability we have discussed, and now we are discussing about capability. How the capability in this what will come? Specification limits are come. So this process is capable or not?
स्पेशल कोटा
this process
कॉमन प्ले
red color
कॉमन में फिर ये एक्सेसिव है कंट्रोल लिमिट्स के बाहर है तो उसको कंट्रोल लिमिट्स
not capable. Yeah, this process is not capable because it is going outside the specification limits, so there will be a rejection. This process is in control and incapable also. In control without any drastic changes in the parameters, only common causes are present and they are producing the parts within specification limits. This is capable and stable, right?
Right.
Okay, same things again we will repeat here also. So you can see capability is here and statistical control is here, right? So this case 3, is it okay?
Yes, sir.
Is it okay?
Yes, sir.
Yes, sir.
How we are saying is okay?
Because for customer,
वो बेसिकली ये समझ बात होती है
see out of yeah,
is yours
then see case 3 there is out of control, because see top side it is out of control only na, out of control is not okay na, right? Out of control means there is a special cause,
वो मांगा था
but process is capable still. You can see special causes are there, stability is not there, anytime it may go outside, right? Here the process is not acceptable and no out of control also, so this is clear, not at all acceptable, not capable of meeting specification and is out of control also. Case 4, case 1 both in control, this is ideal state, you can say in control, you can see in control and acceptable also, which is well within the specification limit.
So which
this
graph
is-
you are talking about?
Yeah, tell me someone was speaking.
Yeah, actually we are not visualizing that. Which graph you are talking about?
No, I am talking about this table only. You just table.
Actually, on our screen,
We have only the graph.
process
Okay.
capability. That is capable of
Okay. What about others? Your screen is like one table is there, right?
No, sir. It's not table. Some program is there within the
Hey.
control.
Just a minute. I will reshare it.
In control.
And right. Please check your this one also, net connection also. If everyone is facing the issue, it might be the issue with me, or else it may be related to individual network issue. Okay. Is okay now? Screen is visible?
Yes, sir. Now it is visible.
Yeah. We are talking about only this one, right?
Actually, that time slide number 34 was
visualized.
Okay. No issues. So again, we will discuss about all these issue. See, this is only the very good process. We can say here it is going outside. Here there are lot of issues. In 4 there is an issue. What is that? There is a special cause, right?
Special cause.
There is a huge variation. Okay. Here also there is some sort of, you can say it is meeting the specification, still variation is there. Maybe common cost variations are very high. Okay. It is currently meeting the specification. Just now it is meeting it may change, but here you can see there is a uniform distribution. There is you can say there is no drastic changes in the variation in control and meeting the specification. Clear? So there is one more thing called as control limit theorem. Just basically you no need to get the deep understanding, but just know what is control center limit theorem. See, the distribution of any data will approximately will follow normal distribution as the sample size increases. So in this case, what I can say, just I will show. Just understand the example only. We are taking some readings and we are drawing data distribution. We are drawing histogram, then we get some data distribution. First of all, our data will be like this. Then sample size may be 10. But then we taken sample size very high, so there will be some sort of changes. Here 20. Then again we are increasing the number of sample size to 1000 or something. So if you are increasing the sample size, it will be directly following a distribution that is called as normal distribution, and it will follow the normal distribution which is called as central limit theory. This is inside the central limit theory, which is a simple principle behind the central limit theorem, we can say, right? Okay, if you are increasing the number of samples, the data will follow a normal distribution. Clear? So we'll come to the measures of central tendency. There are two types of measures used. One is measures of central tendency, and one more thing. What is that? There is one more.
Split. Measure of
one more name is there. One more statistic. Okay. No, I'm talking about only statistics. So central tendency and one more name is there.
Range.
Range, okay. Range is some example, right? Yeah.
Okay, sir.
Yeah, it is dispersion. Have you heard of dispersion? Yeah. Measures of central tendency and measures of dispersion. It rightly said by someone, spread. It is called as, in SPC we use most commonly spread. This is location. So location will be location which will be these are the measures which will detect the location of the data points. That is very important. So it is called as central tendency. So location and central tendency we can relate. Okay. Agree with me? Everyone with me? So the three measures are mean, median, and mode. Mean is already we discussed, average value. Median is the simple middle value, and mode is like most repeating value. Most repeating value. You can say most repeating value. Median is the, just remember, median is the middle value, and so please mute. Please mute. Someone is speaking. Please mute. Okay. Now please calculate all. Please, I request all to calculate mean, median, and mode for all these numbers. I want answers from all.
और इसको सॉर्ट करो ना पहले तो order
Very easy calculation. So I request everyone to calculate what is the mean of this value, what is the median of this value. Right side you can see the values are already there.
38 divided by 6. Mod 3 repetitive है।
ऊपर वाला 5 बीच वाला देखना पड़ेगा बीच वाला 1 है
Filtering you're calculating, Mr. Naveen.
एक ही वैल्यू आनी है।
Yeah, okay.
और मर्जी है हरियर बोलेंगे
When I ask only, just say the answer. Don't say the answer now. Just calculate and complete, and just put the message in chat box. Completed. Each individual can put the messages. Huh?
हिंदी में मजला बोलते हैं मजला
4.5 है एक और 8 को जोड़ के उसका डिवाइड बाय 2 हो जाएगा।
अच्छा 4.5 है 9 आ गया 9 का आधा 4.5
पैसा ही बना दिया सब इसमें
Give 2 minutes.
क्या पूछा इसने
Everyone is doing the calculation.
कैलकुलेट करने के लिए वैल्यू
तो क्या
4.5
Mr. Patel from Jodi World, are you there?
तीनों
नीचे वाला 3 हो गया पीछे वाला 4.5
You can just write down the numbers. The numbers are same for all the examples. Just write down the number. So how many are done?
मैनेज द मिडिल टर्म ऑफ एनी डाटा तो इसमें बोले असेंडिंग ऑर्डर में अरेंज किया इसमें
लिखो भाई
किस वाले को
इन केस ऑफ इवन नंबर्स ऑफ टर्म्स द मीडियन इज द एवरेज ऑफ
वो नहीं लड़का होते हैं फुल वाला लिखा है
Yeah, everyone should be.
Six or three, nine.
Yeah. It's very easy, right? It's done, right?
Yes, sir.
सिक्किम से बोल रहा है सौम्यदीप पात्रा
संदीप पात्रा चला गया
संदीप पात्रा आपने वो पहले का फाइल निकाल दिया कैलकुलेट द मीडियन 4.5 निकाल दिया फर्स्ट रेड है स्मॉलेस्ट टू लार्जेस्ट सेंसिटिव निकाल दिया अब तीसरे का
हेलो
फाइल फर्स्ट स्टेप में ये मीन का ये हो गया
हाँ जी
मीडियन का ये हो गया
बिल्कुल
बताइए उसमें करना पड़ेगा
सीक्वेंस में वो तो मैं बोल रहा हूँ सीक्वेंस में आना पड़ेगा उसको
तब जाने उसको मौका फल है
सर 5 सारे 4.5 मीन का है
Yeah, sorry, it was muted. So everyone has done the calculation, right? This is the answer.
और उसका है 5
So most of the answers are right. So very good.
More than 3
This is a simple, we can say simple this one. And in this, which of the parameters is most commonly used in SPC, whatever study, SPC study? Which of the common, one is commonly used everywhere? What is that?
Mean, sir.
Yes.
Mean
So when
and
we
mean.
talk, yeah, it is mean only. When we talk about mean, so you have to relate it with the process location, right? process mean, or location, how the location of the process is moving, right? Okay. Then one more thing, one more the yeah. Thank you. What still people are putting the answer. Yeah, you can complete your calculation. Yeah. Yeah. So we'll come to the measures of spread. We can say measures of dispersion or spread. Measures of dispersion as a descriptive in statistics that describe how similar set of uh, scores are to each other, right? So in general, there are range. Someone has already
Sir,
said
screen
about
is
the.
not visualized.
Okay, okay, sorry.
Sir, screen is not visualized.
Okay, okay, okay. I'm sharing it again.
Yeah. Thank you.
So now we are discussing about measures of spread, right? Or dispersion. And these are three. That is range, variance, and standard deviation. Okay. What is that? Range, variance, and standard deviation. These two are very commonly used. That is range and standard deviation. When we talk about range and standard deviation, you should remember we are talking about process spread also, right? In that example, the person is getting late means standard deviation is very high or the range is very high and variation is very high and the spread of the data is very high. We already discussed that the person coming to the office and getting late. So you can relate with that. That is spread related to spread of the data and which is related to range and standard deviation, right? So one by one we'll discuss which of the distributions score as larger dispersion. In this you will just which of the just a minute. So just tell me which of the distribution is having larger spread. First one or second one? Top one or bottom?
First one.
First one. First one is having the spread is high.
Top one.
First one or second one?
Last one. फर्स्ट वन में ज्यादा बीन्स बन रहे हैं ज्यादा उसका या
Okay. First one, man. Okay. First
Yes,
one is
it's
having.
larger than the second one.
Yeah, right. Exactly right. So there is a spread is high in the first one, right? So range is defined as symbol one, and it is defined as largest to smallest one, largest minus smallest score we can say. So could you please find out what is the what is the range of this data?
9 minus 1.
Yeah.
8.
Yeah, very good. Huh?
8.
Right. No. Okay, 9 also not that. Yeah. Okay, 8. Right. Okay. So clear range is clear, right?
Yes, sir.
Okay. It's 8. So what is variance? Variance is defined as the average of square root of deviations. You can say this is a formula we don't use much, but sigma we use. Sigma is standard deviation. Square of standard deviation is called as variance. Okay. Okay. You might be so these seen this we can say these formulas everywhere, right? This formula and this formula also. There are some people are using n, some people are using n minus 1. For that there is an explanation that is for population, and some of the data is for only for sample, then we need to use n minus 1. Okay. Standard deviation indicates the amount of variation. Already we can say we discussed the same. When the variation is very high, standard deviation also very high. And that when the employee is getting late, there are a lot of variations. Lot of variation is getting. If he is coming at 10 o'clock, that means during his travel, there are a lot of special causes which is causing very high sigma, very high standard deviation. Okay. Yeah. Any doubt?
So could you please elaborate variance, definition of variance, and what is with the example of that? The real data.
Variance is just we can say squared this one of standard deviation. Variances are not used in SPC. To relate with this, I just given the formula, right? And standard deviation and range we can say is given in the average of the square of the deviations we can say.
It means there is no uses of variance in the SPC.
SPC we are not using variance most commonly, right? After covering the control chart session, you will come to know that. Huh? Range is commonly used in this one. Say in this range is used. Standard deviation is most commonly used, and about the central tendency, mean is most commonly used. Median chart and all we don't use. Huh? Some of the control charts are very commonly used. So which of the control charts are very commonly used? One control chart is very.
Some industries are using median range chart.
Okay.
Median, they have sample size 5.
Okay.
They don't give any calculator. They only calculate it by anything ascending and descending, and they put it.
Okay, right.
That's why median range is most.
Yeah. You are using median also, huh? That chart also. Okay, right. Which industry?
Automotive industries.
Okay, right. Which process, which parameter you are mentioning?
For the grinding or body taper.
Okay.
We are using median range.
Okay, right.
Why we are using this? Because the calculation of mean that is difficult for the operators, because that seat is directly filled by the operators. So we give the number sample size 5. They calculate median.
Okay.
Median range is calculated.
Okay. You will get some clarity or maybe the coming this one slide again. Huh? Okay, right. So again, you can use the formula for standard deviation, and again there is an exercise. You need to calculate again mean, mode, and medium, and standard deviation. You just take the pic of the slide, and or else you can write down the numbers and start calculating. Yeah. Yeah, at least you will start first. You can calculate at least standard deviation, because mean, mode, and medium is already you are done. Just calculate standard deviation. Everyone has to calculate the standard deviation, right?
55 डिग्री का ठंडे देने के लिए दे रहे हो तुम उसको, खुद को ठंडा करने के लिए.
And this is for population data. Here it is mentioned as population data. So use the specific formula.
सही बात है. अच्छा वो इंजीनियर. हाँ तेरे को रिक्वायरमेंट यही है कि भाई वो तो इंजीनियर को देखना है ना, ऐसे कैसे ठंडा करेगा. मैकेनिकल फील्ड है.
कूलिंग डाउन लगा दे.
ये सब चीज हटा कर वो लो बीएसपी. एग्जॉस्ट से तो करो ना चीनिंग. एग्जॉस्ट वेल एग्जॉस्ट तो फालतू है, निकालो उसे, चिल करो, पूरा पूरा चिल हो जाएगा पूरा।
कितना खर्चा आएगा उसमें?
हाँ, ज्यादा नहीं, 2 करोड़। इतना पैसा एक सीजन में मिल जाएगा, वैसे एक सीजन में मिल जाएगा।
पूरा इन्वायरमेंट में वो तो नहीं करूंगा।
नहीं पूरा करो ना, पूरे में तभी इफेक्टिव आएगा, ऐसे नहीं आएगा। वो कर रहा है ये चीज।
क्या कर रहे हैं?
अरे वो मीन निकाल रहा है।
कैलकुलेट द मीन मोड मीडियन।
एक्स दे दिया।
Please write down screen. I'm stopping the screen. Just write down and start calculating, right? Each individual should do the calculations.
बोलने वाले बहुत है।
दो ही चल रहे हैं कार्यक्रम में, एक केटी और एक एमपी। ये एएलपी है बोलो।
Show the last slide. स्लाइड पे दिया।
कहाँ लेटेस्ट लास्ट स्लाइड सही था।
जल्दी हो
दिख ही नहीं देता, लिखे बहुत
दिख नहीं रहा।
भावना समझ ये कहाँ कंप्यूटर में जो लिखा है, ये कीबोर्ड कहाँ दिख रहा है? आप तो उड़ गए
माइक से बोलो
तो समझ नहीं पाएगा।
वो पूछेगा भावना है कहाँ भी समझे।
दिखाया और जब भावना समझ गया।
आगे।
अल्लाह
Yeah, please write down the numbers again. Someone was asking to share the screen.
Someone is मीन है 7.17। यू निकल गया तो x माइनस यू कितना हो गया? 7.7 से माइनस करते जाओ।
9 माइनस 7.7।
हाँ,
मीडियन आ गया 7.5,
लेट
मोड आ गया 8।
7.5 बता भाई।
स्टैंडर्ड डेविएशन
नहीं मीडियन
बता दो
सर। पहले का आएगा 3.35, दूसरा आएगा 0.69, 0.03, 4.71, 0.69,
स्टैंडर्ड डेविएशन बता
1.77।
दे। आ गया 1.34। डाल दें सही से।
डालो डालो
तो मजा आएगा। इस कॉपी हो जाएगी इसमें। लिखिए इसमें मीन लिखिए 7.17।
7.17
मीडियन कॉमा कर देते हैं।
हाँ बोलते जाए यार।
मीडियन है 7.5, मोड है 8, स्पेस है मोड है 8, स्टैंडर्ड डेविएशन ये 8 है। इंटरनेट स्टैंडर्ड डेविएशन 1.34।
See, team only calculates standard deviation. Please focus on standard deviation calculation. Huh? All are doing standard deviation only, right?
अरे सब कर रहे हैं, चिंता मत करें।
1.34।
Naveen and Sajjan.
Yes, sir. Yes, sir.
Okay, Soumya, okay, right.
इसका 1.47 है स्टैंडर्ड डेविएशन।
Mukesh has done, okay. 1.34.
1.34 है ना, सही है।
कैसे
गूगल देता बता दो।
1.47 आएगा। अरे चुतिए
तो यही बता रहा है।
यार ना
अरे वो भी गूगल देख के बैठा होगा तो कर रहा है 1.47 दिया है मीन तो एवरेज ले होगा साहब ने 1.34 लिख दिया लो 35 सबका डेफिनेशन अलग अलग है तो भाई जिसका गूगल से आया वो
नहीं अरे कैसे निकाला ये बता स्टैंडर्ड डेविएशन
चल लिखो
बोलो
मीन आया 7.17 ठीक है मोड आया 8
मीडियन हो गया मोड हो गया
8
7.5 बता रहा था
मीडियन 7.5 है मोड 8 है
मोड 8 है और मीडियन हो गया 7.5
स्टैंडर्ड डेविएशन निकाल लीजिए
स्टैंडर्ड डेविएशन जो है आपका सिग्मा है ना सिग्मा इज इक्वल टू 1/n और समेशन ये माइनस ये
नहीं एक मिनट क्या था फॉर्मूला
सर x माइनस यू मीन डेविएशन उसका स्क्वायर
मोड 8 है
x माइनस यू का होल स्क्वायर
हाँ
x हो गया तुम्हारा
9 माइनस 7.17 सर इसका आंसर बता रहा हूँ 3.35 है उसको प्लस कर लीजिए 3.35 प्लस 0.69 प्लस 0.03 प्लस
very good, Shivakumar, Mukesh. Yeah, Mukesh has changed the answer. Vishwa. Sajjan, Sumesh, Soumya. Thank you, Soumya.
फोटो खिंचाई था
Photo.
फॉर्मूला बता
Was joined from FA Auto. What's your name?
अरे कहाँ है दिखा फॉर्मूला
वो जो है
Yeah, Naveen. Very good.
ये एक का है सर
Okay, Shiva. Okay, thank you.
सिग्मा इज इक्वल टू
1/n स्क्वायर रूट सिग्मा xi माइनस
किसी को बता 1.34 किसी को बता 1.47
Yeah. Just calculate only. Mohan only calculate standard deviation only. Okay, 1.34. Right. Okay.
ये आ गया स्क्वायर रूट x माइनस म्यू
ठीक है हो गया ठीक है
अपॉन n यही है ना
चलो
x माइनस म्यू
Yeah, team.
होल स्क्वायर
Just you can switch on your camera, right?
1.47 ही आएगा
Everyone has done the calculation, right? How many are done? There are a lot of variations in the calculations also. I can see.
हाँ
सम टोटल सम कितना है
टोटल का सम आया है सर 10.84
10.84 into
Yeah, Shivakumar, have you used the formula for population or
55 था ना इसका x
samples?
स्क्वायर होल स्क्वायर
नहीं इसका टोटल का करना है
Because the data is for the population.
होल स्क्वायर का जो आया उसका सम करना है सिग्मा निकालना है उसका एवरेज निकालना है
तो कितना 10.84 आया इसका
10.84
डिवाइडेड बाय
अब डिवाइडेड बाय आपका n है n क्या है 6 है
6 है
So, Soumya, what is your answer?
6
सिग्मा एवरेज नहीं हुआ सिग्मा तो
सॉरी वो सम हुआ
Yeah,
6 करो
1.47, sir.
Okay. Mr. Sajjan, what's your answer?
1.47.
Okay. So, which formula you use for calculation? Population formula, right?
Yes, sir.
Yeah, right. Directly divided by n, right?
वेरिएंस हो गया ना
म्यू क्या है
वेरिएंस का नहीं
N or n minus 1. Some people are
Mu standard
sending
deviation
message, Mr.
म्यू तो
Vinod and Girish.
हाँ
So, for the population, you are getting 1.35.
So 1 n minus 1, sir.
मोर एक्स है
N minus 1. See, this is for population, so you should use only n, right?
4 5 4
Okay.
वो हो गया
Okay, right. So it is, can we break it for lunch? Have you done calculation of all other members?
1.34.
नहीं
Have you completed the calculations?
7 है आपका वो
Who
कितना
is left out?
नहीं
Noida Power Company Limited. Who has done the
वन
calculation
कर
from
दिया
Noida Power
यहाँ पर
Company Limited?
डिवाइड नंबर तो -1
Amar. Okay. Amar, what is the standard deviation?
1.34, sir.
Okay. Who else has done? You alone has joined from the
-1 नहीं है ना
computer
इसमें
or someone else
-1
also
आएगा
joined?
नीचे
Someone also joined. Krishna Kumar Yadav and Gaurav ji also joined.
So 3 people, right?
Yeah, 3 people.
Okay. Who else is there? Other members?
Ital Kumar, sir.
Yeah. What's your answer for standard deviation?
1.35, sir.
Okay. See, in this case, I will share my screen again. See, there are 2 different formulas. Not that much taken care, but still there is a formula for population is taken as n, and for the samples you can need to pay as n-1, right? Okay. This is for population data specifically mentioned here, so you need to use that, right? Okay.
और सैंपल के लिए
So
1.47
yeah.
ये हो गया पॉपुलेशन
Okay.
सैंपल के लिए हो गया
Okay, Tata Auto Components, who has done the calculation? Tata Auto Components.
x minus x bar आ रहा है. x bar क्या है?
हाँ?
Kiran
Minus x bar.
Kiran, are you there?
Yes, sir.
Minus
Yes, sir. 1.34.
x बार कहाँ है म्यू
Okay.
फॉर्मूला देखो.
मेरे पास नहीं है ना मैं तो
आसपास ही नहीं आ रहा. Who is that? Samadhan is available.
In the data distribution.
Is he joined or who else from Tata Auto Components was done the calculation and got the answer? Please try once, otherwise you, Mr. Jodi, have you done the calculation? What is the answer?
हाँ x बार होगा सर
You can speak or you can put it in the chat box while we are waiting for the answer.
Value in the data distribution.
Right.
X क्या लेंगे? Capital X.
कैपिटल x
Avjit Pandey, what is your answer?
9 और ये सब
ना वो तो ये हो गया ना total number of observations.
Avjit Pandey.
हाँ
अच्छा
नहीं
हाँ 9 minus वो 9 वो अलग अलग करके 9 minus
Avjit Pandey, are you there?
तो mu और x bar तो same ही हो नहीं तो population mean हो गया और ये
Bhupesh Yadav,
ये sample mean है इसका मतलब कि 6 का
6 से 1 कम हो गया
1.35
इसने तो
okay, very good.
हो गया x bar जो है sample mean.
Hemant Kumar,
तो हो गया
what's your
टोटल
answer?
नंबर ऑफ वो मीन हुआ
वो तो mu हो गया तो
Hemant Kumar, asking me Hemant Kumar, yeah, right.
सारा को ऐड करके divided by 6 that is population mean. नहीं
हाँ mean मतलब average ना.
So you can calculate what whoever left out, you can calculate and complete and put the same in the chat box. And see, I will be sharing one control chart format with some sample reading. What you need to take, you need to take 3-4 printouts of that, and we'll have an exercise on control chart in the afternoon session. So please take the printout and maybe you can take some pencil or scale for making the graph also. So I will be sharing the document through mail. So your mail IDs have been shared. So I will be sharing with them. And if some of the people wants to share with their HR or coordinator, training coordinator, I will share with them also. So please take the hard printout and you can join the session. We'll have a 1 hour break. 2 o'clock sharp, we will start the session. Okay.
Okay, sir.
Yeah. Please take the printout and come. Huh? I'll be sharing through mail. Right?
Okay.
So I will be sharing. At 2 o'clock we will meet, right?
कोई एक चीज दे रखा है x
Noted, sir.
सेवन क्लास के बारे में दे रखा है
Thank you so much.
नहीं
सेवन क्लास में कितने लड़के हैं वो सेवन क्लास लड़के हैं एट क्लास में कितने लड़के हैं तो ऐसे से पूछे उसका निकालना है
अच्छा तो एक काम हो ना QR कोड मांग लो ना दे दिया भेज दिया क्या
थोड़ा सा तो बताओ
कुछ से भेज दिया क्या
इसके पहले भी था ना कुछ ये थोड़ा मीन मीडियन मोड
इसको दाब दिए और इसको मिनिमाइज कर दिए बस अभी मैं खोल देता हूँ वापस और इसको
Subgroup variation, please.
So the variation, if we take samples, three means three subgroups. So each subgroups contain some variation.
Okay.
So the difference between the within the group.
Okay.
Between the group, between the subgroup means if we take three means three within these three, what is the variation?
Yes, exactly right. Very good, very good. See, inside within the subgroup, that is called within subgroup variation. Between subgroup variation, between these samples, it is called as between subgroup variation. There are two different type of variation, standard deviation formulas used. So again, we are discussing the same thing. This is already covered. Just we will skip on all these points. Just we will read out. See, normal distribution we explained. We had some small discussion about this. This is a bell-shaped sort of distribution, and which is symmetrical. And here you can see mean, medium, mode, and everything is equal. So location is determined by the mean also. Spread is determined by standard deviation. Again, this is related to location and this is related to spread. Normal distribution is a continuous probability distribution that is symmetrical on both sides. It should be symmetrical. When we divide, it should be symmetrical. Here and here, the number of data points will be similar. That is symmetry. We can say symmetry. Between the both the mean you can see between the both sides of the mean the data distribution will be similar. It should be like a mirror image. So when we do any when we collect any sort of data and do the you can say histogram, there will be a distribution like this only. This is normal distribution. Here also you can see this is normal distribution, which is distribution of a very big population, and in that population you may be taking a lot of samples. You can see different sort of 2-3 types of samples are taken. That is inside the population there may be different sort of samples also will be there. Okay. So again, histogram denote some differences between histogram. Histogram will be like this. You can see some data will be there. And then what is the frequency? Like it is almost the data is similar to Pareto diagram. Then there will be some class intervals. From that, what is the scores? It will be noting the frequency of score. You can see in here 0.75 is frequency is very high. Here also 0.885 also frequency high. So data distribution is something like is situated in the middle of 0.8 or something. So we can say distribution. That this distribution is called as normal distribution. So control chart simply, control chart just talks about the process related changes you can detect by using the control charts. So again, normal distribution, again, it is continue. So some sort of different perspective we can understand. See, most of the area, this new symbol is not used. You can use X bar only. Can use X bar. Some areas you can use mu also. For standard deviation, it is sigma, and some areas S also can be used. So for within subgroup variation, maybe you can use sigma. This is for within subgroup variation, and for total variation, maybe you can use S, total variation. In that, you can use the total standard deviation. Sorry, total variation formula can be used. That is square root formula you can use here. Okay. Normal distribution, again, normal distribution, you can see the normal the data is again normally distributed, but it is crossing the specification limit. So here the specification limits are crossed, so these parts are going to get rejected. In this, here one part is getting rejected. It is all about the distribution, how the data is we can say where it is distributed, which score, which point it is getting distributed. That area will become the mean of the process. So it will become the mean of the process where the distribution is very heavy distribution of data will be there. When we go outside of the bell curve, the distribution will be drastically, or we can say directly, it is coming down. So middle, the data will be almost distributed in a very, we can see, high level distribution, and contribution will be very high over here. So the exact normal distribution diagram is here. Normal distribution is often called bell curve because of the shape of the graph of the probability density. Looks like a bell. You can see it's the shape of a bell, so it is called as. It is also known as Gaussian distribution after the German mathematician Gauss has described it. So it is called as even Gaussian distribution also. So this is very important for understanding entire control chart and SPC related. You can, because you need to correlate with the normal distribution diagram, right? Okay. So you can see some control, every control chart. There are control limits. Control limits are set at some unique intervals. So what is that, you know? Here is a process. So they will set the control limits here and here. It is based on something, there is very high difference. How the control limits are set? Do you know how the control limits are properly set? Yeah, please speak up, everyone with me. Yeah. Mr. Mohan, do you know how the control limits are set in control chart? Yeah, Naveen.
Based on our process capability, so we can maintain 50% of the tolerance control limit.
Okay. It's not right what you are saying. Yeah, any other answer? See, it is set at three sigma level, three sigma levels. You can see the control limits are set at 3 sigma level, right? It is set at 3 sigma. Yeah.
Sir, what was your question?
How the control limits are set, I'm saying.
Okay.
You can, yeah.
It's 3 sigma plus and 3 sigma minus.
Okay, right. So why when we ask what is the reason behind 3 sigma is normal distribution, right? No, because of normal
Yes.
distribution, the control limits are set at 3 sigma limits, right? So when we set at 3 sigma limits, you can see here 3 sigma limits, the value of the, you can see 99%, 99.72, we can say 99.72 parts will be coming.
Okay.
Okay.
Will be okay.
Will be okay, right? So
Correct.
to cover almost 99.72 parts, so it is set at 3 sigma level. Okay, still there are some chances, you can say 0.27, 0.28 is still might be a rejection, but very less, right? Still we need to improve. That is why 3 sigma level the control limits are set. Huh? Okay, that is the relation with what we can say. If you set it at least 2 sigma level, your yield will be 95.4. So these values you should at least remember for what is the yield for 1 sigma in normal distribution. It is 68.3, we can say, or 68.26, 95.4, and 99.72 or 73, we can say. So that is the 1 sigma level, 2 sigma level, 3 sigma level, the total contribution of data. Other than this, there will be some parts are getting rejected also in this. So that is the relation with normal distribution and control charts. So again, normal distribution is characterized by 3 factors. One is location. We discussed the process mean and target mean. Just we can consider this is as a target mean, and our process is shifting. So the location of the, we are talking about the location mean, process mean. So it is getting shifted. So these all we need to measure. Then spread. There are spread of the data. You can see here, red color, you can see the red color one is having very less spread. The blue color is having very high spread. And shape here, normal distribution is not followed, you can see, and this is followed by normal distribution, which is equally and symmetrically having values on the both side of the mean. So normal distribution, how we can relate with a real life interpretation, what we can say, when we take the measurement of heights of men in the military, we can say we taken the we are doing some maybe some study related to the height of the person in military. Then we started taking the measurements. Then we have enough data. Then we started maybe preparing a histogram. This is histogram, we can say. Then histogram, you can say 1.73 to 1.87. You can see maybe 1 sigma, 2 sigma, and 3 sigma. Right. In this, what is the mean of the process? Could anyone say what is the mean? What is the mean? Yeah, please speak up. Requesting all the members.
1.8.
1.8. Okay, right. Lika. Right. So how are you arriving at 1.8?
Per max plus so test divided by 2.
Sum of all the heights divided by.
That is right.
Divided by 6.
Yeah, right. In this case, you can see you don't have entire data, right? So in this, you can see this is the middle point. You know this point. So this is the middle point. This is the mean, right? So 173 to 187, that is 14. So it is normally distributed. That is 7 and here, 7 here, right? That way it will come, right? Understand? So here 180. So it is easily understand. See 180, 187, right? This will be 180, as mentioned over here, right? And you can see in this 68 percentage. So what we discussed in the previous slide, just a minute. So we discussed about this, right? So we discussed about normal distribution, right? So yeah, so this is 1 sigma limit, this is 2 sigma limit, this is 3 sigma limit, this is 3 sigma. Understand? Clear?
Yes, sir.
Yeah. That is the we can say standard deviation and variation from the. So from this picture you can see this is 1 sigma to 1 sigma. So 1 sigma means within 1 sigma level there are 173 to 187. This much data is lies between first 1 sigma level, right? 68 point data is in between, means 68 percentage of the person's height is 173 to 187. Agree with me?
Yes, sir.
Yes.
Or
Yeah.
we can say 34%, 34.13% are rejection in that process.
Yeah. Right. Exactly same. So when we go to second, we need to compare with the second sigma level limits. When we go to third, it will be 99.72 or 99.73. You can say 95% data is 1.66 to 1.94, right? So when we go the distribution, when you take any data, when you take naturally it is assume that when we take any data, maybe with a high number of sample, the total data will follow a normal distribution curve. This is normal distribution curve, or we can see bell curve, which is in the shape of bell curve, which is called as bell curve also. This is normal distribution. So you take any sort of data, maybe similar to this height, weight of person, or any of the naturally occurring data, it will follow bell curve. And most of the data, after drawing out a histogram, you will find that almost all these data will fit between the sigma, the variations, whatever set over here, right?
रिकॉर्डिंग हो रही है कि नहीं?
Clear? That is why our control limits are set like x bar plus 3 sigma will be there. Okay. This is basic formula. For this, the sigma formulas and other calculations will be keep on changing for each control charts. The principle is similar one, right? So up to now, everyone is clear with the data, all these basic understanding, right?
Yeah. Can you please explain that R bar, X bar once again, just for 5 minutes?
R bar and X bar. R bar and X bar, we are not started R bar and X bar.
Not started.
Okay.
Actually, 10 minutes I missed it.
Okay. Yeah, we will cover in, we will touching, we'll be touching only one control chart with the details, all details. So, see, most of the principles are almost similar. See, basic principle you need to understand, then you can easily you maybe applying all. It will be very useful. You can, if based on the actual data, you can apply that. Directly you cannot because these principles and basic understanding how it is coming is very important. Then only you can uh, get into the details. Clear?
बीच वाला मीन हो गया ना
Sir,
Yeah.
Sir, my question is this: here the X bar is average of process output, na?
Right. Right.
Okay. Is this formula set on specification limit?
No.
By
No. This formula is not set on the specification limit. This formula is set on the process, right? This is nothing to do with the specification limit, right?
Nothing. Okay.
Okay. That you will understand again. Very good question. See, this is only voice of process only, right? Control chart speaks about the voice of process only, right? Because we can change only one thing, voice of process only. We cannot change voice of customer, VOC we cannot change, right? Agree with me?
Yes, sir.
And one more thing, I'm making it clear again. Again, we may be touching the same. The control limits are defined by process variation. Control, again I'm repeating, control limits are defined by the process variation. Okay, I hope your doubt is clear. Not by the customer specification. Okay? Right. So we'll start with control charts first.
Process variation.
Then we will be touching the template of X bar R chart. What are the things to be filled? Then we'll have a discussion about the control chart, X bar R chart. We will have an exercise on that. Then after that, we will discuss about capability analysis. CPK, PPK will be done. Then after that, the final maybe 1 hour, we will have a feedback and a small test also. So you can join online and complete the test. There will be around, I think 10 to 15 questions will be there, right? So we'll move on to control charts. Most commonly used control charts are for the variable data. It is X bar and R charts, and X bar and S charts, and individual moving range charts or charts for individual, we call it as. What is another name for this chart?
IMR chart. IMR.
Okay. Right. Because of the individual, the name has come. It will take only individual reading. Individual means only single reading. So it is called as individual IMR chart. And some people it is used as XMR, X bar MR chart also, because X is again this X bar XMR it is called as XMR. Sorry, not X bar, XMR also it is called, because X is something like a reading, right? Okay, clear why the name has come, these two? Because you may be seeing some of the materials as XMR also, right? So for the variable data, there will be three commonly used control charts, and for the attributes, for the defectives and defects, there are different control charts. That is P chart for defectives. NP chart is also there. Then C chart and U chart. So these are the overall control charts being used. So based on data and some of the considerations, variable control charts are around the left side, we can see. Attribute control charts are on the right side. There are different control charts which can be used based on what is this?
Sample size.
Yeah, very good. This is sample size. Huh? It should be up to 9 in as per AAG it is 9 only, but you can consider as 9 also. But I think 9 samples most of the industries is not followed, but still it should be between 2 to 9. We can say 2 to 9 it should be there for X bar R chart. Then more than this one we can use this X bar S chart, right? So clear, in this case, maybe depend on the sample size, depend on the sample size, either constant or changeable. They define C chart and U chart here. It is, if the sample size is constant, C chart can be used. If the sample size is not constant, U chart can be used. So what is the difference between defects and defectives?
Defects are number of defects, defect parts.
Right.
How many parts are?
Okay. Defectives are something like one piece is having 2-3 types of defects. Okay, multiple defects will be there, right? Okay, and these are the benefits of control charts. So properly used, if it is properly used, that is very, very important. If it is properly used, so below are the benefits. It should be used by, again, we discussed, or the operator has to use the control charts while doing the productions. Then only the variations can be detectable at the right time, and he can do the corrections and make the process perform consistently and predictably very good for the quality and cost perspective, we can say, and process to achieve higher quality, lower cost, lower unit cost, we can say, higher effective capability, then common language for discussing about the process. Definitely, it is a common language. When we talk about any process, what's the process capability? When we talk about 1.33, 1.5, below 1.5, the people will get a common understanding about the process capability. So that is the, so we can say it's a common language, and the control charts can be used as a common language itself, because the variations coming out of the we can say control limits are defined as special cost variations. The variations which are very natural, we can call it as common cost variation also. So it will distinguish the variations. It will separate out the variations like special cost and common cost differently. So these are the some of the control charts benefits.
रियल उसमें क्या प्रैक्टिकली में क्या implies
So control, we'll start with the control charts for variables. So you know the variable data is like temperature is some sort of an example for variable data. Then weight of the person, then diameter, any of the quantitative data which contains information than a sample without any statement, we can say that is called as variable data. And variable data is having different type of control chart can be used for variable data, and one control chart which is commonly used is X bar R bar chart for variables. So in this, we can say, although measuring the data will be a task in what we can say in variable control data, it is more costly, we can say, because measurement is involved because of the measurement. But still, in this case, more meaningful, we can say, meaningful study can be done for variable chart. So variable control charts reliable because fewer pieces, we are not taking all the readings, we are taking fewer pieces to make the decision, or to make some improvements. So we can say that is some sort of it's not like 100% we are checking all the parts. With the variable data, performance of the process can be analyzed. Definitely, performance of the process is analyzed by using the data, and improvement can be quantified, even if all the values are within specification limits also. Because this is important that seeking never ending improvement. See, even if your data is stable and capable of producing the parts also, you can go for next level of improvement by doing some sort of improvements on common cause variations. Again, squeezing the limits. Again, you are improving the process capability of the process. By doing that, you are improving your process, and you are making, we can say, we are enlightening the customer needs, customer expectations. You are going beyond the customer expectations, and making very good quality products. That is, we can say, even if you remove the special courses and your process is existing with common courses. So what is related to control charts? Okay. So what are the control charts used for attributes? Please spell out one by one.
P
What are
chart
the
and
yeah,
P chart
P chart
and
is
NP chart.
P chart, and I'm talking about what control charts for attribute charts. Yeah, P chart and one more NP chart. Okay, then
U chart and C chart.
C and U.
U chart,
okay,
U
right.
chart.
C chart.
Okay, right. Okay,
Hello.
okay, right.
Yes, sir.
So P chart for constant sample size, or
ठीक
same
Variable load.
sample size?
ठीक है
Okay, very good.
आज की
Right.
डेट से होगी वो
So variable
ठीक
sample size we use P chart. So for NP chart it should be same. For the P charts also, it may be changing, or it may be the same also. But C chart we cannot use changing sample size. Constant sample size can be used for C chart. And for individual reading, we should use XMR chart or IMR chart, right? And sample size between 2 to 9, we can use X bar R chart. And
टू टू डी
for this one, more than 9 samples, if the sample size is more than 9, you can use X bar S chart.
ये डी क्या है सर डी क्या दिया था उसने?
Okay. And
वो कार्ड दिया था
so
ना
we'll discuss about again how the subgroup, what is the standard of subgroup selection, which is specifically related to maybe automotive standard, we can say. So in this, they will determine, see, when we select the samples, you can say, when we are selecting more samples, is it good or bad? Do we need to select more samples, or how is that?
more
So I just we will take that rice example. No, we one person was purchasing the rice, so he was checking the rice quality by taking the samples to take the decision on. He wants to predict whether the rice is good or bad. So for taking a decision, was doing a sampling, right? So in that case, see, maybe you can see the sampling. If you do if you do at least sampling if more than 5 6 samples larger than what we used to do regularly. So what is that? Taking more samples is good or bad in
Taking more
production of
samples is also
yeah.
Good.
Yeah. Yeah, please, you can say what is your opinion about the sample selection. Yeah, already some of the people are already doing the sampling inspection, right? Yeah, Mr. Naveen, please, Mr. Naveen.
Yes,
Yeah, it is better.
for taking the decision for taking the decisions it is better, but it is lengthy.
Okay, very good, very good. So we always for see that we need to consider our what we can say sampling cost or inspection cost also, no? So based on the standards, we need to we should not leave any variations out of our control chart or any. We should capture almost all variations, right? Then only we can arrive at a maximum result out of our control chart. So that is there. So do you know what is the standard for? There are some specifications, some standards, some quantities already defined by AAG for taking samples. So what is that? Do you know what is that? A number of samples we can say, or no, maybe the case of sample size also we can say.
Five, I think five number of samples.
Yeah, so sample size is 4 to 5, right?
Correct. 4 to 5.
Yeah.
Right, sir.
Yeah, subgroup says we can say subgroup says is 4 to 5, and minimum we can say 25 samples to be taken with the size of 4 to 5 subgroup size. Okay, so it will be almost 25 into 4. It will be 100 readings. What 125 readings will be there. Okay.
Yes, sir.
Okay. Okay. Here we you can see some of the terms which is used as again rational subgroup. Rational subgroups are like
एक sheet में एक sample करता हूँ.
variation among units within a subgroups. We need to eliminate within subgroup variation. We should avoid. We should be
करना पड़ेगा.
keeping
तुम्हारे लिए
within
चलो
subgroup
है.
variation very less
पूरा लगा.
unleased variation, and the other total variation properly, right? So rational subgrouping explains the same thing. So within subgroup variation should be because we take the sample, so it should be consecutively. So when we take 5 samples, so should we take it randomly or consecutively? How we need to take?
Continuously 5 samples to be taken, not randomly.
Okay, okay. So any other answer, Mr. Who is this? Balaji, what's your answer? Yeah, Amar, you are saying something. I was not able to hear you. Yeah, tell me.
Collection of sample in between equal intervals.
Equal intervals, right? You between equal intervals, that is sampling frequency, we can say. But you have decided to go for 4 samples. So 4 samples, how we will take consecutively or different stages?
Different stages.
Consequently, sir.
I think it should be. I think it should be
Consecu-
random sample.
it should be consecutively as per AAG standard. It should be consecutively 5 samples to be taken, because these
Trend
five
होता है सर.
samples representative, we can say a small lot which is having similar sort of variation only. They don't have much variation within that family, we can say. That is why within subgroup variation which should eliminate. Clear? That is why consecutive samples are preferred. Okay? See, if you don't take the consecutive samples also, there may be changes in between also, very drastic changes, right? So we cannot find that, right? So
Right,
as
sir.
per as per just follow the standard. That is consecutively you need to take the samples, right? Clear? Again, yeah. So you can see it is written in the bold letter in the last slide. You can see maybe. So here the 4 to 5 samples consecutively produced in the process, and you can see the afterwards the lines also you can measure represented in a single tool, single head, whatever it is. It should be from the single process tree, which may not have different type of variations like operator is changed something. It should not be there. Insert has been changed, grinding wheel has been changed, some changes has been. It cannot be there. Okay.
यहाँ
So subgroup frequency, again, frequency you can define based on your outputs, how most of the process follows hourly ones. So at the starting of the shift or at the end of the shift, you can decide where to take the sample. 4 to 5 samples you can take. You can note down the this one readings. That is sample subgroup frequency, you can say. Number of subgroups, again, same thing has been repeated. That is 25 or more subgroups containing 100 or individual and more than at least 100 readings should be there, right? This is defined by AAG SPC second edition standard. Okay. So X bar, will go to X bar R chart. So similar sort of calculations, X bar and I think R bar, there will not be any confusion for the calculation, because mean is calculated by is adding total readings divided by number of readings, and the range is calculated by highest minus lowest readings. So the characteristics should be plotted on X bar R chart. X bar R chart will come on the top, and sample range will come on the downside. So that is a flow of we can say control chart, how the format will be there. So you can see the same thing in your format, whatever I shared, right? So in that you can see how many this one has provided, like samples are provided. You can say what is the sample size is what is the sample size fit into that control chart format.
वो X bar
Is it 4 or 5?
वो सिंपल भी
Subgroup
था
size I'm saying.
1.82 जो आया था
Okay, 5 we can set into that format, right?
10.82 कैसे आया किसका?
Okay.
अगर ऐड है तो टेम्पो डेट टू कैसे आएगा? ऐड में
Right.
तो नहीं आएगा। सिग्मा दिवाली का एंड था ना।
Sir, what is A2 here?
Which one?
A2. A2 is the constant is taken now for.
Yeah. This is something, some constant has been defined, huh? So there is a table also will be provided with that. So you can just see the number of samples based on, in your case, in your example, what is the sample subgroup size? I have given the data also. You have taken the data printout also, right? Everyone has taken the printouts, right?
वही तो ये पूछ रहा है।
Yes. You have the data also, right?
Yes.
Okay.
डाटा देगा अभी।
नहीं तो प्रिंट आउट कह रहा था कि प्रिंट आउट निकाल लिया आप लोगों ने सब कह रहे हैं।
So there is a formula for calculating UCL and LCL for R bar chart. Then for X bar R chart, you will be using this formula. And standard based on 5 means A2's value will be, you need to see A2 value. What is the A2 value? That is 0.58, right? And for D4, you need to use D4 here. That is D4 value for 2.11 will be the D4 value. Okay. So before going to that, we'll just explain the control charts, right? This is, so in this one more thing, X bar chart is for to monitor the central tendency, right? So you may be wondering why X bar is used, why R chart is used. Huh? So this is the hello. Yeah, right. Someone is speaking if your voice is not audible, right? So range charts is for the process dispersion. We already discussed this. So this is the format has been shared with you. You can see. I will explain one by one. Plan name will be there, and then department, then operation you can put it here. Then date you can mention here. It is provided as date. May be defined by the date of control limit setting is provided over here. Part number you can put it over here. Sample size is 5. Sample size is mentioned here. And then sampling frequency, hourly or by maybe every after 2 hours or something you can mention. Then what is the characteristics, like you can measure outside diameter, inside diameter, or something, whatever the process parameter you can mention. Machine number, date is mentioned over here. That is all about this one. And same all these what we can call constants are provided on the control charts based on the sample size. If you have 5 samples, if you have 4 samples, you just see the 4 sample and what is the value used in can be used for A2 that can be defined over here.
वो जो
D3 there will not be any.
टू कैसे आया?
Sir, my question is how to decide sample size.
See, sample size is already defined by
डेविएशन जो निकाल रहे थे
that sample size only, right? And based on the process, if you want, if it is all defined by the customer only, based on your process. If you are not following any customer related things, at least you follow basic standards.
It is defined based on the process, na? So is there any calculation to find out the sample size?
No, there is
or
no
any
calculation.
formula is there?
No calculation. 4 to 5 samples to be taken. It is already I have explained, right?
So sometimes 3 samples are taken. I have seen in some industries.
इसलिए
They are taking three samples.
साहब और इनके लिए है ये
Three samples mean you are talking about sample size or subgroup size you are saying, na? This one.
Sample size.
Okay, right. It depends.
निकालो तुम भी सैंपल ऐसे
It depends
we
on the
can
customer.
decide it should be
डेविएशन 0 हो
3 or
जाएगा
5 or 7 or 10.
माइनस मिनिमम है ना
हाँ?
See, based on sample size, this control charts also will be different, right? Yeah. See, if you are taking very less samples, what sample size, what will happen? You will not get exact idea of how the process is behaving, right? If you are taking only very less samples, there will be an issue. You will not get a proper study. The values will not be meaningful, right?
My question is that suppose that I want to implement control chart at my machine.
So how much parts you will produce?
No. Hourly I can measure that sample, but how I decide how much sample need to check at a once? 3, 2, 5, 7, 10. Because here, if I feel 1 to 10 samples are there, and number of samples which are measured.
You can refer this one, na? This one samples, this chart.
That I can refer this for the type of the control chart. My question is how I decide that X bar R chart will be used. If I decide 4 to 5 subgroup number of samples in a subgroup. So how I am deciding 4 to 5, 1 or more than 10?
You are into which industry? There is a standard, na? So that is already fixed as 4 to 5 samples, right? So you need to follow 4 to 5.
So sometime 10 samples are using. That's why that table is given. So my question to understand that how we decide number of samples to be checked in a subgroup.
Minimum is 4 to 5. You can extend up to 10. That can be done, right?
Correct. So how I am deciding it should be 8, it should be 9, it should be 7.
You can decide. See, that is why for that you need to follow the AAG standard, and based on your there is a cost involved. Na? You will not take something 10 and you will keep on taking the readings. Huh? Your operator will be start complaining, I cannot take the reading. There is an operational this one. You cannot question something which is already followed by all the industries, right?
Okay.
Yeah. Operational cost is very important because you cannot, if you can capture the variations by taking 3-4 samples, why you should go for 10? There is a, we can say there is a technical, this one common sense can be used, the common sense also can be used based on the inspection, because some of the areas inspection takes a lot of time and we may be losing our production. So we cannot do that, right? So if there is a purpose, we need to capture the variations. If the purpose is done with 3-4 samples, we can go ahead with the minimum 4 to 5 samples, right? So based on that, we can take the decision. So that standards up to 10 is provided because of this. You can see different. Up to 10 it is there. So for extra they might be using that constants. Okay. So again coming to control charts. So here you can see if you take the readings as the first hour. So in that example, I think only 24 will be there. I think 24, right? Please check your data. How many readings are there?
It's 24. 24.
Yeah, 24. Yeah, he has taken 5 samples. Maybe, yeah. Just for example, we can take that value and we can do the calculations, right? So here, basic things in this is ready control chart. You can see. You can see the upper control limits, that is one part. Then LCL, that is a lower control chart, and this is process mean. This is process mean, right? In that it will be X bar or X double bar. Yeah, please mute. Someone is speaking, right? Okay. So this is X bar or X double bar in your example. Whatever the values I have given, no? Same.
X bar.
Mm-hmm.
X bar.
Yeah, any other opinion? Here you already calculating the X bar, na? See, understand. Here you already calculating the X bar. You can see X bar is here. You see your format. I'm testing the same, right? X bar is already calculated, right? So again you are taking it is X double bar, we can say. Understand?
Yes. Yes, sir.
Yes, okay.
In
Nothing. Just taking the process mean, no? Use anything X bar, X double bar, something different. See, we need to calculate our control chart name is you can say see X bar and R chart, right? So here you need to do the calculations, right?
पहले सारे सैंपल जो लिए
In this
वन वाला जो वो एक्स बार आया उसका फिर उसको proof क्या है?
so this is one of the thing, and every control chart now nothing is printed on the back side, and the back side of control chart this process log sheet will be there. This is called as process log sheet. So you will be writing date, time, any commands like insert change, tool change, something is happened, part is okay, not okay. All of the changes will be power failure, something happened. So we are capturing the, what is that? We are capturing the
Data.
why this process log is. Huh? I'm not I'm not able to hear you properly. Yeah, someone was saying something. Yeah.
हाँ जी कहाँ कहाँ
This is used for capturing the special causes variation, any causes of variation, right?
हाँ आ जाइए बैठ जाए यहाँ तो
Okay. That has been written on the backside of a control chart. It is very important. So when we go some sort of some control chart, you can see some of the values are going up. So you can easily find out what is the issue, right? So now you can take this example sheet. Please take this example and just start drawing the same.
मुझे कौन सा मैच हो रहा है
You have the graph also, right? There is a dark line that you can take it as a process mean. X double bar, I will consider as X double bar. Okay, so one, two, just so everybody, please just wait a minute. I will be giving some values which is related to that. Then you can go ahead with the calculations.
पब्लिक रहेगी ना साथ में और खुश हो
You
जाएगी
need to calculate X double bar from the values given, right? And R bar also you need
गलत
to
हो जाएगी ना
calculate.
तब यही होगा फाइनल चल रहा है तो बोलेंगे 3 फाइनल करते हैं अच्छा 3 में से जो बेस्ट 2 जीतेगा वही होगा
आधा टाइम तो अपना काम कर रहा है बंद कर देता है
सोचता है कौन सा स्लाइड दिखाना है। हाँ स्लाइड ओके वी कम
So see, please note down. X double bar is 30.166. Please note down. X double bar is 30.166.
बोल रहा है आंसर बता दिया है आप कैलकुलेट कर लो।
And for R bar, it is 0.004.
इसमें कुछ करने की जरूरत नहीं होती, उसमें एक्सेल में ना सीधे एक बार वो करो, सेलेक्ट करो उसको,
वही तो मैं कर रहा था,
राइट क्लिक करो, उसमें जाओ सीधे सीधे अपना पूरा निकाल के देगा सारा।
स्टैंडर्ड डेविएशन निकालना है क्या
सब कुछ
निकालना
निकाल
है
के देगा सर।
So you need to do the calculations as per this Excel sheet. First of all, you need to do you just note down the points on the X bar R chart you need to prepare. So X double bar value is 30.166. Then you can have the readings like 36.167, 168, 169. That way you can put.
choice sample size कितना आपने इसमें?
Team, please calculate UCL, LCL. This value, both the values I have given. Now you can calculate UCL and LCL first before starting. Then you can draw this graph. This value is already provided. Then just take it directly. X double one, I am repeating, 30.166 and R bar is 0.004. I will write you.
नहीं ये हर एक्सेल में है या एक्सेल में नहीं सारे एक्सेल शीट में ये
हाँ हाँ
एक्सेल में ये अलग से आता है उसका ऑप्शन खोलना पड़ता है। ये डाटा दिखा इसमें डाटा इससे मेन स्टैंडर्ड डेविएशन मीडियन
ये क्या होता है स्वीटनेस स्वीटनेस ये रेंज
ये अलग अलग से निकालते हैं।
So what is the value for UCL? How many are done?
Standard है।
How many are done with the calculation of UCL? Just calculate UCL first.
30.168.
Okay. Okay.
30.166.
Yeah, please. I request all to calculate the same for X bar chart and R bar chart.
मतलब पहले दिन दोनों
भैया लगे हुए हैं बिजली वाले एक बार बोल तो दिया वो लगा हुआ है आपने क्या जबरदस्त
30.168 तो आपका हो गया UCL
और LCL की करवाई
30.163
168 कर दो LCL X bar 6 LCL X bar L4 हो जाएगा
मैंने इस फोर लिखा
Sir, UCL 30.167.
UCL for what? R chart or X bar?
X bar chart. X chart.
X bar chart.
LCL is 30.164
Okay, right.
for X bar chart.
चलाने कंप्रेसर
And for UCL for R bar chart is 0.008 and LCL will be 0.
कंप्रेसर नहीं चला।
Okay.
हाँ जी। अच्छा अभी देखता हूँ ऐसे कैसे हुआ
पता नहीं
गोविंद ने बताया नहीं होगा।
नहीं वो कह रहा है मैंने भेज तो दिया था पूछता हूँ ठीक है।
Sir, what is x value for
ये
x?
सारे हमारे गायब होंगे लप्पू सुप्पू सब कोई होगा।
What do you ask? I didn't get
Sir,
you.
sir, what value we can consider for x?
Value is given now. There is data is already provided. There is a table provided with.
Sir, screen is not visible.
Yeah, the data is provided with the control chart format. I have shared through mail the data.
ये जो कंप्रेसर
You're asking the same, right?
ये कंप्रेसर
Intercard also.
इमरजेंसी
Yes, yes.
इंजेक्शन
Yes.
इमरजेंसी पैनल है वो वाला कंप्रेसर चलाना ग्रिड पर।
Now you can take appropriate scale and start drawing this X bar and both the chart you can prepare.
हाँ उसको चलाना ग्रिड पे लोड कराओ ऐसे एग्जॉस्ट लोड कर दिए उसको चलवाओ ग्रिड पे चलेगा वो ठीक है उसको बंद करवाओ कंप्रेसर चल गया। हेलो गोविंद है क्या सर? हाँ
एक मिनट बात करना
गोविंद। अरे यार ये टरबाइन पर लोड क्यों भरा दो ग्रिड पर लोड भराओ ना टरबाइन पर तो ऐसे एग्जॉस्ट बोल रही है यार। कोई नहीं
At least complete it for 10 data points. No? There are 24 data points. At least 10 data points you complete and show it to me.
बंद थोड़ी करना है कंप्रेसर इसको ग्रिड पे कैसे चली है कैसे है बताओ तो पता नहीं ग्रिड पर सिंपल सीधा सीधा रास्ता है इमरजेंसी डीबी है शुक्र की उससे कंप्रेसर है सिंपल वो इमरजेंसी डीबी उसी से चार्ज है वो वाला चलवा दो आप सप्लाई घुमाओगे फिर वो करोगे फिर रात में कोई दिक्कत आएगी फिर वो करना है पता नहीं कैसे आप लोग नहीं ग्रिड के लिए तो बोला था लेकिन ये 6 नंबर से चलाया है बातें सारी पूछा करो कहाँ से कौन सा कंप्रेसर चलाया कौन से सप्लाई किया क्या है इंस्ट्रक्शन दे दिया काम खत्म। मिश्रा जी के सामने तो आधा हमें इनकी वजह से वो होता है काम।
So control limits are done. So I hope everyone has calculated the control limits for the both charts. X bar and R chart. Now you can draw the chart.
नहीं यार छोटा भी तो
इंश्योरेंस वाला
उसको
मैंने इसको बोला तो कंप्लीट किया तो पहले से ये रखा था बार बार बोलते हैं मैंने तो अब से बात कर ली और उसको बोलते हैं सुनाने में 2-3 दिन लगेंगे और तुम मेल कर उस चार्ट को लेकर उसको फोटो लगाकर मेल पर अटैच करके ऑल द डॉक्यूमेंट्स हैज बीन फर्निश्ड बाय द इलेक्ट्रिकल डिपार्टमेंट एक्सेप्ट ये इट विल टेक 2 more days क्या ये मेल
Actually, D3 is not given. So it means 0 or
बात उठेगी
Yeah, D3 is you can take as 0. It will be 0 in this one. R chart you are saying, na? LCL. Yeah, right.
तो गया नहीं यहाँ तो 1:30 बजे लोग चले गए
क्या करें
अरे वार्म अप तो होगा यार वैसा हो जाके वार्म अप हो रहे हैं घर पर
गोविंद वहाँ प्रैक्टिस कर रहा है
स्टार खिलाड़ी है वो उनका तो फिर उसको वार्म अप होने की जरूरत है।
डबल स्टार है
अरे हम इधर से देख रहे हैं सर ठीक है
किसके साथ है
आज ज्ञान के
वही
नहीं नहीं केन में है।
अच्छे 2-3 लोग हैं
हाँ,
तो
2-3
हमको
लोग
कंट्रोल कर लिया तो कुछ नहीं करना सीधे गुड लाइन बॉल निकालते हो जैसे उधर डालते हो और कुछ नहीं करना इधर उधर वेरिएशन ये सब कुछ नहीं करना मतलब सलाह बोलो थोड़ा आगे जा रहे हो वो पहले प्रोडक्ट
और चेक करा ना डीबी 12 पर ही है ना। हाँ जी हाँ तुमने पिछली 6 बता दिया हमने कौन सा को लाइन पे ले लिया।
ये तो ये चार जब वो फाइल ही नहीं हमारे पास तो क्या करेंगे हैं फाइल तो है ही नहीं हमारे पास तो उसको प्रैक्टिस करवा रहा है
तो फिर वो 6 बताया था कोई इमरजेंसी कैसे चला दिया तुमने। नहीं कोई नहीं लेकिन चलो ठीक है।
ये इतना शुगर के लिए इतना इम्पोर्टेंट है जितना रूट कॉज एनालिसिस है उसमें वो ज़्यादा इम्पोर्टेंट
वो ज़्यादा
उसमें है पहले तो 4
वो चाहिए जो रूट कॉज एनालिसिस का हुआ था।
हाँ
वो सेंड कर देता हूँ।
कब हुआ था
सीजन में
वो बढ़िया है
वो बढ़िया है।
और फिश बोन डायग्राम वाई वाई ये सारी चीजें जैसे आपका प्राइस और ये रेशियो 80-20 रूल बोलते हैं 20% चांस बहुत सारे नाम।
So anyone is done with at least 10 readings? At least 10 readings I'm saying.
क्या दे दिया?
First 10 readings you can complete.
वो प्रिंट आउट हमने निकाला है ना ये जो काम बता रहा है ना ये कंसल्टेंसी वाला काम ज्यादा है कि वेरिएशन कितना आ रहा है आपका काम क्या आ रहा है ये तो करते हैं ना जो जैसे फार्मा वगैरह है ये बड़ी दूसरी वही वो टिपिकल जो इंडस्ट्री है जहाँ मतलब क्वालिटी है उस पर है ज़्यादा ध्यान उनको सिक्स सिग्मा का यहाँ पे यूजिंग है
Amar Shankar, have you done or?
नहीं सिक्स सिग्मा
Could you please show me your graph? Control chart.
ये कहता है कि अगर
Give me 1 second.
Yeah.
Just a second.
थर्ड बेल पे उठना चाहिए फोन अगर थर्ड बेल पे नहीं उठा तो सिक्स सिग्मा नहीं है ये वही है तीन डिफरेंस 1 मिलियन के अंदर बहुत सिक्स सिग्मा मतलब उसमें प्लेन में बताया था उसने 0.00001 फॉल्ट ऐसे करके 3 फॉल्ट पर नहीं है 3.664 है
की गुंजाइश है आने की
उससे कम होना चाहिए उससे कम होना चाहिए
सेगमेंट 5
और 600 करीब हो गया तो आपको 5 सिग्मा है 1000 करीब 4 सिग्मा है इससे करीब इसीलिए तो आप देखो कॉल सेंटर में घंटे बजते ही
Shiv Kumar, have you completed?
घंटे रिंग
At least for 10 readings.
नहीं वो काउंट में नहीं आता जब उसकी जैसे ट्रांसफर थर्ड बेल को उठना हमारे यहाँ बहुत सारे ऐसे हैं कि घंटे बजते रहते पता ही नहीं चलता
Vinod, have you completed? Vinod from Violia. Have you started?
Sir, completed.
Okay, I'm okay. Give me some time.
How many readings you have done? Okay, good.
I think
Amar,
this will be
Amar, you can. Sorry, Vinod, 1 minute. Yeah, bring it, bring it. Yeah, very good, very good, very good.
Very good, very good, very good.
Somewhat near, you can bring it near to the camera again. Yeah. Okay. Have you drawn the control limits also? No. Okay. You can draw the control limits also. Huh?
Okay,
Okay.
okay, okay. Okay, sir.
Okay. Okay. And yeah, yeah. So any of the other members has been completed with at least 10 readings for any of the graph, either X bar chart or R chart. You please show. Yeah, Mohan. Yeah, yeah, yeah. You're starting with R chart. Okay, okay, right, right. Control limits you can put, right? Okay. So central line is taken as 0.004, right?
0.004.
Yeah, yeah, yeah. Hemant Kumar, are you there? Hemant Kumar.
Sir, now please check.
Yeah, yeah, okay, 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 right, right. Very good, very
बगल
good.
में वो बना रहा है
So what about others? Are you doing the same or Hemant, are you there? Sheetal Kumar, Hemant.
Yes, sir, I'm drawing.
Okay. How many readings are done? You need to switch on your camera and show what you have done. Just show how you are doing, huh?
I'll just complete and show you.
Yeah, okay, okay, no issues, no issues.
If I slightly confused in UCL X bar. What is X? X, what is the value?
That is process mean. See, control limits are set from the process mean. That is
Okay,
X
okay.
double bar.
X double bar. Okay, okay.
The value is already I shared. 30.1.
But X and X double bar both are same here.
There are some difference that by seeing the table you can understand that. I will explain that. Okay. You are taking the average of X bar again, it will be X double bar. Right? First time it will be X bar. Then it will go to X double bar.
Okay. In the X we have to write X double bar.
Yeah, center line is S double bar in this case. Yeah. That is 30.166.
166.
What about Sajjan? Have you done? Sajjan, Udit. What about you, Bama? Am I audible to you?
Yes, sir. I have done the X bar chart, R chart.
Okay, okay, right. Kiran, are you doing the same?
Yes, sir. Yes.
Okay, very good, very good. Balaji, have you done with the chart or how many readings you have done? Balaji Jebel.
हाँ सर, हमारा नाम लिया तो क्या बोलेंगे? देखिए साइज में कितना चाहिए।
हाँ वैसे ही है
वही नहीं है जो हम भी मैंने भी अलग से देना बस उसके लिए अलग है
requesting all to complete this exercise. So we can take a 5 minutes break. Around 3:30 we can join back again. So if someone is not completed, they can complete their control chart also.
What is the value for D3 bar chart?
It is provided in the data table. If it is no value is not provided, it can be considered as zero.
So in extra chart, what is the value of A2 we should consider? Or if it is not given, then we should take it 0.
A2 is provided in the data table, right?
So can you show the slides? It is not enough. Can you display the tables?
Sir, where can we find the value of D3, A2?
5.5 मीटर 6 मीटर बाई 6 मीटर वैसे है ये दरवाजे ECC
No such value is there in the table.
हेलो हाँ जी हाँ जी सर हाँ जी सर गुड आफ्टरनून ओके और उसके बाद फिर बात में ये डिसमेंटल करता हूँ फिर से ओके और अब मेरे को 6 महीने के लिए कुछ बिल्डिंग कुछ वेयर हाउस टाइप बनाना है उसके बाद उसको मैं 6 महीने बेसिकली पूरी इंडस्ट्री जो 6 महीने चलती है वर्किंग में 6 महीने जब मैट्रेस का काम चलता है तो हमें कुछ वेयर हाउस की रिक्वायरमेंट होती है तो हम जिस मोटर रोलिंग करनी है मेरे को तो मेरे पास फैक्ट्री के अंदर जगह नहीं होती हम क्या करते हैं बाहर टेंट लगाते हैं या उसमें शेड लगा कर उसे और उसको डिसमेंटल करके फिर वापस रेंटल बेसिस पर भी करते हैं क्या भी काम कितना टाइम लेते हैं चलो वैसा भी क्या मतलब नहीं आप प्रोफाइल शेयर और आपको कॉन्टैक्ट नंबर भी दे दूंगा सुविधा सर लेकिन 3 महीने काफी ज्यादा हो जाएंगे हमारे लिए आप एक बार मेरे को कोई प्रोफाइल और नहीं वो सब ठीक है सर आप मेरे को कोई इंस्टॉलेशन सब उसकी फोटोग्राफ्स दे दीजिएगा हम अपने यहाँ बात करके देखते हैं आप मैं अपना ईमेल एड्रेस देता हूँ आप इसको मैं टेक्स्ट करता हूँ आपको ठीक है हो गया क्या सर ये सबसे कैलकुलेशन सबको शीट दे के निकल ले
यस सर हाँ जी हाँ जी आगे चलेगा ना में आप 40 बाई 40
Hello. Yeah.
अच्छा अच्छा ओके तो आप स्टोरेज एरिया के हिसाब से आप ओके ठीक है
So I will check your control chart. If time is there, we can check it out in the final hours. So we'll continue with the session.
मैं जो हमारे गोडाउन्स के हमारे जो हैं निर्देश मैं शेयर कर दूँ आपको कमेंट होगी जैसे टेम्परेरी गोडाउन बनाना होता है उनको कभी कभार ठीक है
Nikhil sir.
Yeah.
ठीक है इतने सारे पैनल तो हमारे
This is to get the exact what is being done for the study, SPC study. So in this case, you can see only 24. You need to take at least 25 with the sample size of minimum 4 to 5. You can consider, right, for XMR chart. Okay. So everyone is done with at least you have started with your control chart this one drawing, right?
Sir, one doubt, sir.
Okay.
Sir, in this X bar chart, what will be the x-axis value and y-axis value, sir?
लेकिन ऐसे में क्या है कि हजार
What we should plot for in x-axis?
X-axis for product parameters, right? Product parameter, whatever the parameters, based on the what you can say the readings, you can fit your scale based on that.
ऐसे तो लगा नहीं सकते
And for y-axis, sir?
ऐसे तो लग ही नहीं सकते ऐसे ही लगेगी ऐसे लगाने में भी अगर दोनों एक साथ लगाएंगे
No, that is timing. Timing. That is number of samples.
Okay.
Number 1 to first hour. First hour will take some reading. So first hour reading should be the first one. Then second hour, third hour, fourth hour. Okay. Okay.
Nikhil sir, we have one more query regarding the sample size group. Basically, we are getting confused with the selection of number of sample subgroup. How much? As we have seen that there is a group of 4 to 5 samples will be taken as per the standard.
See, one more thing. Let me explain. So these are the standards being because defined by AIG, and in this also there are some deviations which can be done with the communication with the customer. So that is also done, and these I can say even I have interaction with most of the industry members. In that if I could find there are a lot of difference in using control charts. No one is taking 100 readings. That is the same thing you are going to discuss, right?
Yeah, basically the which is shown in the last activity that there is a as per the sample size the chart will be different, will be used. For one sample size will be used IMR chart. For 2 to 9 we have to use X bar chart, and for greater than 9 we have to do another chart. So we are getting confused with how we will select, how we will identify which chart we will use, and on what basis we will select the sample size in our process. On what basis? This is what we basically want to know that.
See, in your case, what are you manufacturing? See, based on their standard and requirement, they have set this standard because they have done some studies also, na. That is why they have done. They have fixed as at least 100 readings. At least it could cover some sort of variations. So you cannot see there is no specific requirement because you see one company is producing only 3 parts hourly.
Okay.
3 parts. So in that case, how he will take 5 samples? You just explain. He cannot take it, right?
So on the basis of
Actual
number
situation is
of
very
hours.
important. How you are producing, how the output is coming, that is also very, very important, right? Your customer will not say if you are, because some industries you can see only one product is coming out of 1 hour. So what will happen? You will not go for X bar or chart. Which chart you will use? Which chart you will use?
IMR chart.
That is there. That idea. The thing is that we don't know details about our standards, so we don't have any doubts, right? When we know, when we coming to the picture and learning something, now we will get lot of doubts. That is SPC is very big. You can learn deep. So that is there with the SPC. So I request everyone to focus and keep learning the same thing SPC, because if you learn today something, you will have 5 6 doubts. So again, keep on learning. You can by day by learning you can maybe cover almost all the things related to SPC, because SPC, once SPC you are done with SPC, I can say MSA, some principles are very easy to understand when you do SPC, right?
Yes, sir.
Okay. Yeah.
Thank you, sir. Clarification.
Yeah. Right. Also, we'll continue with. We'll check your control charts if time permits, or else we'll continue with the session. We need to discuss capability also. Sound is not moving. 1 minute. Okay. So same things again. So it will be almost similar like this. You can see in R chart there will not be any lower control limits. That is mentioned in the in this whatever you can say control chart also it is mentioned, right? Have you noticed the same thing? There is no LCL, right? Here it is mentioned below sample size 7, LCL should not be there. So technically it will be a negative number, so it is not considered. Okay. So that is there. Then this is log chart. In here we write down what are the changes we do. So then only we can at least refer for a history. Maybe if want to see any changes. So changes are happened because of some non special causes that can be noted here, right? If you have any non special causes, you don't need to take any actions, right? Agree with me? You know something is happened. You know the reason the part is coming out of the control chart. There is a reason, you know that. Then you don't be prepared for that, because the some of the actions are very what we can say like insert changes. Some tool changes will definitely will result in parameters changes. Agree with me?
Yes, sir.
Okay. Right. Same. Okay, this reading has been done. Okay. This is related to mean and range chart. Mean X bar and R chart only. The see the difference how X bar R chart is functioning. Like X bar chart detects the shifts. You can see shifts are detected, but R chart you cannot see any shift. Out of control limits parts are not here. Understand? See, process is shifting. You can see process is shifting. Process mean is shifting. But in mean chart only you can find out the changes. Here there will not be any changes. R chart.
Yes, sir. In R
Yeah.
chart, X bar chart, one dimension goes upper specification control limit.
Right.
R chart is okay.
Yeah, right. Similar for this reversal also, it will be for spread changes also. If your spread is increasing, definitely upper value to sorry, max to minimum value should be reflected in R chart only. So R chart, that value will come out of that. So it will change. It will show a change in R chart. This way, both the charts are used together. So in some areas, based on this one, some people changes this mean as some median. Someone was speaking about median also. Some people are using that also. Okay, so S chart I already explained. This is for sample size is in this sample size will be very high. So standard deviation is used. Standard deviation R chart is used. Yeah, S charts we can say standard deviations are used in this. Large sample sets are used, and more efficient measure of variation is appropriate because in this standard deviations are used. So remaining calculations and all, there were some minor changes, but the drawing, the purpose will be similar. For IMR chart, I am again explaining when the measurements are very expensive. So in that case, we cannot take much reading. So our sample size will be very limited. So any sort of destructive testing, after testing the parts get rejected. So in that case also, IMR chart we cannot take, we cannot reject parts for taking the readings. Some of the parameters like homogeneous, we can say process parameters will not change for a long time. Maybe for 2 hours it will be same, then after 2 hours it will be changing. So getting a lot of readings will be very tough. So in that case, IMR charts are used. So similar sort of attribute charts. For attribute charts, there are 4 charts. That is, one is C chart, then U chart, then NP chart, and P chart. So sample size will be different in one chart, and one is in one chart it will be constant. So in the case of in attribute charts, the readings will be defects, counting the defects, number of defects in a single piece. This is applied at the maybe end of the, we can say, inspection area, or operator is inspecting there also. We can wherever the attribute data is available, there we can use this. So again, these are the formula for entire we can say P chart or entire attribute chart. You can say so the control limits formulas are there for upper control and lower control, and based on the subgroup whether it is constant or changing. So getting into process capability, so this is much more important because PPK and PPK calculations and changes, what are the differences we need to understand. So see, some of the areas I explained for SPC studies, Minitab is being used. So some basics about Minitab things we can cover up in the slides, because we manually, because it is not easy to check some of the parameters. So that is there. So see, first of all, to calculate the process capability, what we can say process capability values, there are some what we can say, there are some specific requirements. What is that? Now we are done with the control chart and everything. So we need to do the capability checking. capable. We need to calculate the SPC and all. So, what is the minimum requirement for that?
The process should be stable.
Okay, very good. Yeah. And other than that, yeah, other than that, any other examples? We should be, there are some specific requirements.
One more thing, study should be done over the time, multiple
Right, right. That is,
multiple
yeah.
operators, multiple types.
Okay, 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 okay. Okay, you are talking about MSA. Yeah, right. That is related to MSA, right, 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 right. Okay, any specific requirement other than this? Any?
Machine should be capable first.
हाँ, okay, okay, right.
यूट्यूब में डाल रखा है इसने वो वैसे डाउनलोड नहीं हो पा रही थी तो यूट्यूब पर अपलोड कर दिया था उसने
One question: this data which we are getting, or the readings which we are getting from the samples, that should be
Okay.
measured in the same particular particular location only, or it can be randomly randomly checked at different locations.
No, no, no. It should be it should be checked in the order only. That is very important, right? If you take the parts, yeah, it will be an issue, right? Agree with me? This point.
Yeah, but this is similar to MSA. MSA study is similar to this one, right?
Okay, okay. MSA, we are no, we are not talking about MSA, right? Yeah.
There also we are taking the readings which are which has to be taken in the same time.
Yeah, their purpose is entirely different. You can change the part here and there. There is no issue, right? There you are measuring either operator performance or either the gauge or measurement gauge, whatever you're using. Their performance, repeatability, and reproducibility you are measuring. Here we are more focused on the product, right? Okay.
Yeah.
Yeah. There, that is not important. Here the time is very important. So when the variation is happening, whenever the issues are happening, there we need to take the action. When you take one part and you checking at the end of the shift, and you cannot take any decision. You don't see like FIR you do na. Whenever some murder happens, we need to go to the Gemba and we need to see what is happening. So same principle applied here, right? Agree with me? Yeah. Okay. Yeah. For capability study, yes, definitely special courses should be removed. When you remove the special courses, it should be in the process control. We can say process is in control without any drastic, unpredictable changes will not be there, and data should be normally distributed. Data should be from a normally distributed thing. It should not have any data like some data insert has been changed. That data is put into the control chart, and it will give some unwanted variations. And the data distribution should be normally distributed. And in Minitab, you can enter your data and check your normality. It is called as normality test. So normal distribution test can be done. If the normal distribution is okay, you can directly go for process capability study, or else maybe you can gather more data for this. So don't worry about this. If someone is using for next level learning, for identifying and going into the deep details of we can say SPC, you can learn all these things, because in Minitab there is a option called box cost transformation. From by doing that, maybe your data is getting transferred into normal data. So that is there is an option. Okay. So one more thing, this is what we discussed about process should be stable. You can see all the limits, all the readings are within the control limits. You can see the within control limits. These are the control limits, and special cost variation should be removed. And one more thing is very important related to studying process capability. What is that? Which is related to MSA. We should do MSA before or SPC before? Which has to be done before? Which studies should be done?
So MSA has to be done before SPC.
Yeah, very good. MSA has to be done before because your gauge and measurement system should be properly okay, and it should have minimum error, right? Okay, very good. So again, we need to check the normality. Again, that same thing I explained. There is an option for a normality test. You can see. You just put the values over there, and you can go do the normality test. And there is a test you can call as Anderson Darling test. This is a test normally used. By clicking on this, you will get a window like this. This will be the probability study. Yeah. From this, you need to see the p value. It should be greater than 0.05. If it is greater than 0.05, please note that p value is 0.05, greater than 0.05. It should be normal. Just I'm skipping because this is related to Minitab. So someone wants to learn Minitab, just they can start using Minitab also. So some of the data you can see which is not normal. You can see value is below 0.05. You can see the data is not normal. Some sort of C by model this sort of distribution. This is this may be due to some of the issues. Data is not correct. Data is not properly collected. So it will happen, and this also will happen. See, if not symmetrical, data is not symmetrical, this is also not a good sign. Here also you can see the data distributions are not correct. So in this case you cannot use that. So properly data collection is very important. So non-normal data, these are the reasons. Maybe due to some boundary conditions, due to some variations, due to some process cycle variation. Sometimes process will be producing very maximum specification parts, or maybe biased measurements, measurement issues with the gauges, very high issues with the human factors. These are all specific, we can say, special causes, and we are taking the readings with all these conditions. Will be very difficult to calculate the process capability. And if you calculate the process capability with all your measurement system, with the bad measurement system and all, you will not get exact process capability readings. So your whatever the samples when you are taking, you should be more careful about these prerequisites about the capability studies. So first of all, again, we are concluding about the process capability pre-requirements. It should be stable, and data should be normal. It should reflect a normal distribution. Data distribution, we can say MSA needs to prove measurement system is acceptable. So that is also very important. These three things are very important before getting into process capability study. So in control, I think almost all of you know about the removal of special courses. That's okay. After that, it should be MSA also. There is a requirement. So this is a requirement for MSA. Just for reference, I kept it as so minimum. It should be see gauge. To say gauge is okay as per AAG. MSA is under 10% GRR value should be below 10 percentage. That is considered as okay. Okay. So we'll start with capability analysis. There are different process indices being used. So first of all, first process indices is uh, capability index. Then we will touch on performance index also. So CP and PP and then variation related CPK and PPK also will be touching, right? So CP.
There is one question.
Yeah.
When we have to calculate when we have to go for CPK and when we have to go for PPP.
Okay, right, right. See, it depends on the, you can say, I will show, we will discuss about CP and CPK and PPK. Then you will come to know that when you can use. It all depends. Actually, even AAG doesn't declare that you need to use only CPK. Based on the situation, you should use even CPK and PPK, right? All these Minitab softwares you can see they are using CPK and PPK together, right? You cannot use it only CPK at the only using CPK. There are some issues. You will get a clarity just after this discussion. We are coming to that point. In AAG standard, it is mentioned that we cannot use a single index. We cannot use it. You can see and you can refer this standard. See, you cannot refer a single index for defining your process. It depends, and you need to use maybe multiple indices at a time. That is why I hope Minitab software has been doing the studies with both the indices together. CPK and PPK will come after you enter some data, then you go for capability studies, the readings will come PPK and CPK together, right? Okay. And CP is we'll discuss, that is voice of customer and divided by voice of process. That is just so what is the formula we use for what is the formula?
That is the tolerance.
Yeah.
Use USL minus LSL.
Yeah, right. Very good.
That is the voice of customer.
And what is the voice of the process, we can say? I told there is a 3 sigma limits, 3 sigma all we discuss normal distribution. Right. That is
Six
why.
Sigma.
That is why this 6 sigma is coming. You are able to relate, right?
Correct. 3 positive and 3 negative.
3 here and 3 here. Multiplied by variation. So it will come here. So total variation. We are comparing process variation with the customer specification. Okay.
Sigma is dispersion here.
Yeah.
Okay.
So we need to, what we need to do, we need to reduce this one, right?
Right.
If you reduce this one, CP value will be increasing, right?
Increase.
This we cannot do anything, right? Voice of customer. Okay. So if you increase like this, what will happen? Our process will not be capable, right? Our variation is high, right?
And CP will be decrease.
And whatever the parts coming out these slides will be
Rejected or out of
no, in this case it is rejected only. We are discussing only
within specification, but
right.
They can be reject. There is a chance to be reject if we don't adjust the machine's center.
Okay, right. Okay. So then CP calculation you can see. You can see in CP calculation the sigma formula is R bar by D2. We discussed in standard deviation. Huh? This is R bar by D2. Okay. Formula for we can say this is sigma. We can take it as sigma. And one more formula. What is that? One more formula is there. What is that? Yeah. There is a formula, no? Square root, square root, square. Yeah, yeah.
X median minus mu whole
Yeah,
square
yeah.
divided by n.
That is also we can call it as standard deviation. The catch is here. The catch is here. The difference is here. You all need to understand the difference between CPK and PPK is based on usage of this sigma. Understand this standard deviation. In CP or either CPK, we use this formula. In CP or CPK, we use this standard deviation formula. We can call it as sigma, and here we use S square root, whatever the square root formula is there, that formula being used in PPK. Okay, with me, most important thing, we are getting into the most important details about capability studies. Okay, clear. Yeah, Mr. Amar, yeah, clear. Yeah, Vinod, are you there? Yeah.
Yeah, we are here.
Yeah. This is why there is a change. Okay. So how we are doing is entirely different. That is why maybe because of people are not aware, or people maybe because standards are defined. You can see standards are defined only by this way only. Formulas are available. Everywhere you can Google out, but the difference is only this one. You can see, and some more details we can discuss. But we follow something else that is entirely different. Huh? That maybe we may be doing the mistakes from years, but it may not be true today. Huh? You can correct also if something is maybe against all these learnings. If something is happening, you can even you can ask doubts also. Okay,
Sir,
right.
what is PP here? CP is potential index. And PP? What is PP?
PP is not there. No? PPK, process performance index. I will discuss coming slide. Wait. Okay. Okay. Right. Again, we will come to the. For this D2, you will get a table, and there is a standard. Huh? Based on that, you will get it. See in here, you can see. Again, we come to this. See, this is this we can call it as. Sorry. See, this we can call it as customer specification. This we cannot change. Just an example, you need to assume something in this example, right? Which is against the real thing, right? Still, this example is good. That is why I selected this one. See, this is something car parking. Our walls are called as specification limits. Okay. Now, in this, which car is good? When you park your car, which car you select?
Green one, sir.
Green one, right? So green one is having the variation very less, right? Green one is having the variation very less.
Correct.
Right. In this case, you can see we call it as what is that? See. voice of process and voice of customer. Huh? So our voice of customer is this much, and if you are taking this much, it will be very risk. So same thing is happening here, huh? With the orange car. It's a condition. So it is almost touching. Still, maybe small gap will be there. What happens when you have some sort of changes in your process, you will scratch your vehicle. Come down. Still, there are issues. Still, he is maybe process is creating some sort of bigger issues, bigger variation, still it will touch because only the gap is very less. So our intention should be the gap should be very high. Then only whatever issues you can see the car size is very small. So even the whatever the readings, whatever the product parameters is shifting here also, it will not hit, right? It will not hit. Simple thing I can say. Just we are drawing a control limit based on the process parameters, and we are limiting our car in the inside this area. We are limiting our car inside this area, and we keep all these everything outside. So making the parts very safe by reducing the variation. This is a entire SPC, CPK job, whatever it is. This is the entire simple word I can say. This is a simple principle behind that. Okay. Clear with this example, right?
Yes, sir. Yes. Clear.
Okay. Divided by both are same means the value will come 1, right? Because CP value will come 1, right? Right? If the variation, see, if the specification is this and your variation is double, it will go to 0.5, right? This it will come down. So this process is not good, right? Always there will be a rejection. Okay. So same. That is why we meant by using this formula CP. But it is not considering the sender. So location of the location of the spread is location of the value is considered in CPK only. Okay. Yeah, someone wants to ask anything? Yeah. In this you can see in this we can call it as CPU upper CPK, we can call it as this is lower one. Based on this, which is minimum value, we will consider as CPK. We'll calculate both and we will find out the minimum value. That is called as CPK. Here also sigma value will be R bar by D2 because this is related to CPK. Okay. Okay, in this you will be focusing on the location also, mean of the value, how the mean is shifting. This is the actual requirement and processors shifted here. So based on this, it will measure the shift also. So it will measure the distance to the, you can say whether maybe LSL or the mean value, how much is far from the mean value, how much is far from either LSL or USL. If it is near to this, it will get rejected. So we'll measure which is very near. So we'll take it as CPK and we'll take an action. That is the principle. Okay. And And CPK review, it indicates how many process distribution bits can be within specification limits, we can say. And it does not, you can see in this, again I'm saying, CP considers only the spread of the process. CPK considers both the spread and centering of the process. We call it as centering of the process. Where the process is situated, both it will be considered in CPK. That is why CPK value is used. Okay. Next we'll come to the PP. We call it as performance index.
Mukherjee, there is a question.
Yeah.
If LSL is not there, or if it is for unilateral tolerance, then what will be the LSL and what will be the USL?
For unilateral tolerance, you cannot calculate CP and PP. Huh? You cannot calculate. There will be issue. This is for bilateral tolerances only. Okay.
Bilateral tolerance.
And for performance index, which is called as PP and PPK, we can see the calculation formula remains same, but here you can see the sigma. I told the sigma formula will be used as S, that is standard deviation formula. Yeah.
Can you please show the before slide? So one more before, please.
This one.
Okay.
This is similar things only.
Similar. Okay.
Yeah, in this you can see this S formula, it is not mentioned over here, but you can mention that the formula which is mentioned over there. Square root formula is used here. Two way we can use. The only difference is that we explain the same thing in next slide also. In PPK, the standard deviations are considered for total variation. In PPK, only within group subgroup variation is considered. See. So PPK covers all variations. You can see all variations. CP considers only small variations within subgroup. Why? Because it is related to R bar. So R bar, how it will come? So you have some readings like 1, 2, that, so 6, 8, 9. So this is specifically related to one subgroup, right? Yeah. Yeah.
Symmetrical हो सकते हैं, asymmetrical हो सकता है.
So this is between PPK and then PPK review. This is called as performance index. See, we can compare and learn. That will be better. See, PPK shows the process is actually meeting the customer requirements or not. So,
sir, when CPCPK and PPPPK study is done, what is the difference in that?
See, nowadays it is specifically mentioned that some conditions we need to use both PPK and CPK together. See, it is based on the data how we are selecting and based on the standard deviation calculation, right? Right. See, standard deviation formula is different in both cases.
No, sir, I understood the formula of the calculation. I just want to know when PPPK study to be done or when CPCPK study to be done. Is there any difference for long-term studies?
No, that is not, we can say that is not specifically mentioned. For PPAP studies, what do you use? I'm asking if someone is doing already. For PPAP studies, what do you use?
CPCPK.
Yeah, anyone from any other opinion?
Yeah, we are conducting the PPPPK.
Yeah.
Before mass production.
Yeah, yes. Okay. See, it depends. Some people are using PPK and some people are using CPK also. Generally, regular production times, we can say only CPK is used, right? General production time, you will not calculate PPK, right?
Yes.
But if you are using minute tag means you will be using both nowadays because you need to consider both. So it will to that level of understanding, you can say based on the customer. See, customer, you can contact your customer during PPAP. Then you can have a mutual understanding, and then you can use which value can be used. It depends on the number of how your process is means distribution data, how the data is collected. So it depends on that. And even most of the teams use sigma formula, right? R bar by D2, right? R bar by D2 is being used, right?
Right, sir.
Right. So see, and one more thing is CPK is called as within subgroup variation. Standard deviation is used. Short term, we can say short term, which is used as short term. So this includes, but in PPK it includes total variation. It includes total variation, you can see. And total variation formula, that is S, standard deviation formula, S is used. So PPK will be considering this formula. This diagram, you can see PPK using all variations, all changes will be considered. So what will happen? PPK value or CPK value, which will be high? Sorry, yeah. Which value will be naturally high? CPK or PPK?
PPK value will be higher.
No. PPK value will be lower.
CPK.
Huh?
CPK.
CPK value will be higher. Huh?
Yeah.
Because CPK value is depend on based on this bottom level, this one. You can see 3 sigma is there. So if your sigma, in this case, if you're taking all variations, sigma will be high, right? Agree with me? Sigma value high means automatically this value will be down. In CPK, sigma consideration is only for within subgroup variation. So CPK value will be somewhat higher than PPK. That I will, maybe some examples is there, we can show that. So could you please, you can say if time is there, you can calculate same thing for your, what we can say, you have already these values with you, right? Could you please calculate CPK and PPK for that process? You have USL and LSL. I will be sharing the same. Just I will share that. Specification is mentioned in that diagram. No calculations. Just wait. So have I got the specification for the previous reading what I shared with you? No, right? Specification is not there, right? So please take the specification as sharing. Yeah. I'm sharing one specification. 30.157. You can note down 30.157.
Sir, can you repeat?
30 point. Just I will write and I will show you. 1 minute. I'm sharing my screen, right? Yeah. You can take this specification 1 minute. Yeah, this specification you can take 30.15 to 30.175. Please note down. Then I will show the formulas soon. So everybody is noted down the same. So we'll go to formula. First of all, you need to calculate. See, in this case, you calculate only CPK will be better. Yeah, you can calculate CP and CPK here. Yeah, specification is mentioned here.
तो 105 स्लाइड है 106 बराबर कितने होते हैं कौन से कर ले किससे कर ले पीछे कर दे ये लाइन मतलब 99 हो गया लगभग को देखा है
So got the answer, everyone?
Sir, 1.75.
1.747.
If 3 decimals are there, your answer also should be 3 decimals. Huh?
1.747.
I want everyone should get the same answer.
7.747.
Okay, any other answer? You can calculate CPK also. You can calculate CPK also.
1.06 0.0 यार उस पे लिखा हुआ है मेरी सी
So what is the value for CPK? What's the value you are getting? Yeah. So what's the value you're getting for CPK?
1.746. It is coming same.
Okay.
Almost 1.746.
Okay. 1.746. So any different answers? What is the standard deviation value you are getting? Some differences. Okay, right. See, so you got the answer. I'll be displaying some of the standards also. Yeah, CPK values, please tell. How much you are getting?
1.747. 747.
747. Yeah. Any different answer from anyone? Yeah, just I'll check the chat box also. Hope everyone is doing the calculation. So have you done with your calculation? You're almost done. See, the requirements of AAG, I will share the requirements. This is the last slide. So if you have any doubts, you can ask 1 minute. So what is the value you got? So as per this AAG requirement, it should be minimum more than 1.67. So 1.33 to 1.67 is agreed. Below 1.33, we cannot take it as an acceptable product, we can say. So in this case, you got what is the value? 1.7 you are getting, right?
Yeah.
Okay. So CPK is okay, right?
Yes.
Yes. Okay. See, we have left out with 30 minutes, and there will be a feedback form sharing with you all, and just a online test also will be there. I request all the members to attend the online test also. You should submit your test results also. You can open that. I will be sharing the link. Just open the link and you can answer the questions and submit. You can by using mobile also, even you can do the same thing. So before that, you need to submit the training feedback form also. So before going to that, if you have any doubts, you can ask. If you have any doubts, you can ask.
Sir, this SPC control chart methods and calculation of CP values, is it followed in chemical industries or only in machinery manufacturing tools industries?
See, you can follow based on the requirement, because I don't know whether if chemical industry some standards are already defined, you need to follow or adhere to that. Otherwise, you can to improve your process. Definitely, you can use CPK and PPK values. Yeah.
That is, for example, the customer specification for a product, they bring the impurity, the maximum specification is given, which we can take it as the upper specification.
Okay. Only one
Impurity,
sided tolerance, it will be very difficult.
so
You
there
cannot.
is no lower value. Zero
You
is
okay. Okay, okay. In that case, you cannot use. There are some changes. Huh? In that case,
can the company internally have an lower value and work out on these values? Is that
yeah,
possible?
yeah. That way you can do that. Huh? Right.
The lower value the company has to set.
Yeah, yeah. Specific in some specification you can set and make the process the sender, because it all depends on centering and target sender, so target main, all these. Huh?
And then one more
Okay.
doubt, sir. In
Yes, yes,
selecting the
yes.
sample and the subgroup size.
Okay.
For production, we are producing in metric tons. 24 hours production, we take it as 1 batch. Normally, we produce around 20 to 25 metric tons per day. The
Mm-hmm.
samples are bagged, and each metric ton is bagged separately. So, if I want to calculate the process capability for a particular impurity parameter in the product.
Which parameter?
For impurity.
Okay, okay, okay. No, one minute. Someone, 1 minute. It is getting disturbed. Amar, please mute. Yeah, yeah. Abama, just 1 minute. See, I will be sharing. I'll be sharing the training feedback link in chat box. I request all to update that, just to submit that, and then some after submitting the feedback form, just put a message that you have submitted the feedback form. So I'm sharing the feedback form for the training. So yeah, Bama, you can continue. So which parameters
मैं
you
कह
are
रहा है
going to
तो कोई है
measure,
नहीं
that depends. So how many samples you can take? If the sample sizes are very less and you are not able to take much readings, you can make
मैं
the
कह रहा
use of
रिकॉर्डिंग को सेव करके
integer
लैपटॉप
moving
निकाल लूं
range
फिर
chart. In that case, it will help
एक
you.
बार तेरे पास किसका फोन आया था उससे बात कर लूं मैं बात करता हूँ
Yeah, any other doubt? Others, if you have any questions, you can ask.
Sir, what is the best value for the good process of CPK?
Yeah, I will share again. It is more than, it is defined as more than 1.67. Yeah, I am
Sir,
sharing.
why
Yeah,
it is
right.
1.67?
Why it is 1.67? There may be
अभी चल रही है,
some
क्या करना है
calculations
इसमें?
behind this, because you see, one means what is that? What you understand? What is meant by one?
One means total speed is using, variation is touching your USL and LSL.
Right, right. So based on that, AAG has defined this. Even I don't know exactly why they are defined 1.67, right?
Okay.
It will be more than like 1.33 is you can see here you can see 1.333 to 1.67 is somewhat is okay. Second one. Yeah, right? Because keeping if we keep one, what will happen? Directly process will go out, right?
सर ये मीटिंग कब बंद करनी है जी?
So keep in mind, see, I told
मैं तो
you,
यहीं
we
हूँ।
My
always,
question is, sir, why
yeah,
it is
yeah.
चल रही है कॉल भैया बीच
1.6?
में
Why
जी,
it is not
समझा भी दें कुछ।
1.6 at? How it is calculated? It could be
चलने दो।
1.65, 66, 67, 6 at. Why it is
ठीक।
1.67 only?
That reason even I also don't know about that, right?
What I understood, sir, tolerance is USL minus LSL now equal to 6 sigma.
Yeah.
Correct? If my process is 3 sigma,
Yeah,
if
99.73.
my process is 4 sigma, then 8 part will be there. So 8 by 6 is, I think, 1.33.
See, that is you are saying
4 sigma
normal
processing,
distribution. Yeah, yeah. Four sigma means eight parts.
8, 8 divided by 6.
Okay, okay,
And 5 sigma means 10 divided by 6. It is 1.67.
okay,
And if
okay.
you are using 50% of the tolerance, then 12 means 6 sigma divided by 6. So it will come, CP will come 2.
Right, right, right. Yeah, yeah, yeah. That is
Am I right?
shifting. The same. That may be the reason. Maybe because you can see we always want to reduce our variations to the center. So our values, if Six Sigma process means there will be six.
CP will be 2.
Yeah, yeah, yeah. CP will be 2. That is okay. 6. We can divide the variation into 6 here. 6 standard deviation can fit here. 6 can
6
fit
here.
here.
Correct.
Yeah, yeah, yeah.
Correct. Correct.
Yeah.
Am I right?
Basically, I think yeah, it is taken as 3 3. That is 6. Yeah.
Okay, sir. And if CP is 1 means 3 3, 6 by 6, 1.
Yeah,
Fully
yeah.
speed.
Right, right, right. Yeah, please start giving the feedback form also. I have shared the link in chat. To be able to fill this, please do that. And I will be sharing the same through mail also. You need to submit both the feedback forms also. Feedback form and first of all, you need to complete the feedback form. I have shared. Yeah, feedback. Okay, please complete all. Dinesh will be sharing some of the slides with you. No issues. Okay. So complete the feedback and put it in a chat box. Just message you can put it in your chat box. I have completed in the similar way. So after completing the feedback form, I will be sharing the test paper link also. So someone has already submitted. Yeah, Girish. Yeah, I received from Mr. Girish. Yeah. Thank you, Dinesh. Yeah. Yeah, I request all to complete the feedback forms. Then only we can start the session. Test, test paper we need to do. So please complete the feedback form and submit. Amar, Mohan, Shidal, please complete. Vishwa, Kiran, please complete and put it in the chat box after completion of your feedback. How many are done? Please. You can speak also, or else you can put the message also in the chat box. Shivakumar has done. Okay. Shivakumar. So who else is left out for feedback? I received only 10 to 11 feedbacks only. Please complete. Hemant Kumar, have you done that? Hemant. Rajesh Padak.
Then we have submitted the feedback form.
Yeah. Okay.
So did we get the certification also for that SPC training?
Yeah. You will get it. First, you need to complete the test also, right?
Acha, okay.
Okay, yeah. You need to complete the test at least within 5 o'clock. I request all to complete the test also. So within 2 minutes, I will be sharing the test link also, online test. Before that, I request whoever left out for feedback to complete their feedback form. Yeah, Naveen, thank you. Yeah, Naresh, thank you. Okay, thank you, Soumya. So whoever left for feedback, so I got it. I got it from only 18 members. I request all to complete. Thank you, Mohan, Sheetal, Soumya. Balaji, have you done the feedback form? Done with the feedback? Bisaranjan, yeah. Bama, thank you. Yeah, right. Right. So it has to be submitted for each individual, not for the companies. So each individual should submit both the test and feedback form separately, not for the company. One person submitting is not okay. Yeah, out of we can see 21 is received. Yeah, thank you, thank you, thank you. Yeah, I received again 24. I received again out of 10 to 15 are left. 10, at least 10 to 12 are left. Yeah, Kiran, thank you. Yashodhan, thank you. So, Krishan, have you submitted 2 times? Amar, have you submitted 2 times or how is that? Yeah, Kiran.
Yes, sir. I have submitted 2 times for me and Krishna Kumar Yadav, both.
But the names should be different.
Yeah, yeah,
Okay.
yeah. I have done that correctly.
Okay, right, right, right. So, anyone is left out for feedback? Still, some of the members are not submitted. Please, please complete. Yeah, Sumesh, thank you. Mosam Khan, Viswaranjan, Udit, have you done? Have you completed the feedback form? Have you submitted? Udit, have you
Yes.
submitted?
Yes,
Okay,
sir.
thank
Yes,
you.
sir. Already submitted.
Okay, Viswaranjan.
Yes.
No, I'm asking Viswaranjan Gowda. Hemant Kumar, are you there? Hemant Kumar.
Yes, sir, I'm here. Give me some time. I'm just on a call, urgent call.
Oh, okay, okay, right. Okay, Harshal, thank you so much. So meanwhile, Please complete it. Others are waiting for the test also. So please understand, complete the submission of feedback form. Again, some of the members has to be submitted. Yeah. 9 to 6 members to be submitted. Yeah. Sajjan, Mr. Sajjan. See, I have shared the test link also. Now you can submit your test also. But who are not done with the feedback, they need to submit feedback first. Then only you can access the test. So I request all to complete their feedback. Whoever completed their feedbacks, they can start taking their online test also. Yeah, Sachin, you might be facing any internet issue because I am allowing you. You are not able to connect. The test link also shared. You can see the chat box. You can see Harshil. You can see the chat box.
Yes, I was searching for the link. I couldn't find. I'll search again.
Link is already shared in the chat box. You can see. I'm sharing again. Same.
Yeah, if you can please share it again, that will be wonderful.
Okay. Okay. Yeah. I'm sharing again. Yeah. So anyone is left for feedback? I need to receive from at least 4 to 5 members again.